All right, hello everybody. I would typically say welcome back because we have a lot of familiar viewers on the channel here on both LinkedIn and Twitch where we stream to. But I know that we have quite a few new audience members for the first time this week. This show is called AWS What's Next. It's a show from us here at Amazon Web Services, the technology arm over at Amazon, to talk a little bit about some of the latest launches that we have. But you're probably wondering why this may be relevant to you, because many people watching may not be software developers themselves. Rob, why don't we introduce ourselves really quickly and sort of give people the lay of the land here for this show?
Yeah, I'm Robert Zhu. I'm a developer advocate for Amazon Web Services, and I'm one of the co-hosts of the show.
Yeah, and my name is Nick Walsh. You can probably see our Twitter handles and titles down there. But we're really excited to host this show. Largely us, as our jobs, we are software developers that help to make this technology that AWS builds more applicable and more relatable for not just general audiences, but for software practitioners themselves. We're alluding to a lot of things that will I think make a lot of sense very quickly as to why you might be seeing this. But in past episodes, we've covered a lot of different things, from databases to new forms of virtual servers. But AWS builds a lot of very exciting pieces of technology. And this week we have some ones that we think you will particularly enjoy. I don't want to tease things too much. So Rob, why don't we let people know what they're in for in today's episode?
Yeah, we have this joke that every episode we establish new heights in terms of the excitement of the announcements. But this one, I'm gonna repeat that old cliche. Today we're talking about AWS IVS. I feel like I don't even want to spoil this, but for all of you Twitch viewers, this is going to be especially exciting, especially relevant. We're going to be diving deep on the tech that powers Twitch and how it can enable you to launch your own channel. This is some really exciting stuff, and I can't wait to get into it. We have some really special guests, the foremost experts on the topic, so I can't wait. Nick, you want to talk about DeepRacer Evo?
Yeah, exactly. So topic one, obviously, IVS, interactive video service, but topic two will be something that's exciting for, I think, everybody. We're going to talk about AWS DeepRacer. This is an autonomous, machine learning powered RC car, essentially, where you can train your own machine learning model for autonomous driving, load it onto this vehicle, and then see how it performs. There have been some really exciting changes for things of the model like object avoidance and the ability to use 3D depth sensing. I know that may sound very technical, but I promise we'll make it a lot more clear in that session itself. And as is typical with this show, we run with 3 announcements. So Rob, I know we have a third one that'll be coming up after DeepRacer.
Yeah, and that is AWS CoPilot. So if you're using AWS, or if you've been software infrastructure for the last couple of years, you're probably working with containers. You've heard of containers, and if you're on AWS especially, you've probably heard of some of our offerings with ECS and Elastic Container Service, Elastic EKS, Elastic Kubernetes Service. Well, the space is getting kind of complicated, and it's sometimes difficult to make a quick decision about what the best infrastructure is. And we've constantly been building tooling around that to make your lives a little bit easier. And that is the next step that we want to talk about with AWS CoPilot.
Awesome. Well, without further ado, because I figured this first section may take us quite a while to get through, we have a lot to talk about in it. I figured we could introduce our first guest for Amazon IVS. That is Martin Hess, GM of Amazon IVS. Marty, what do you prefer? I want to say thank you for joining us, but tell everyone a little bit about what you do.
Thank you, Nick. Most people call me Marty.
Okay, awesome. So GM of Amazon IVS. Now that's a lot to unpack there, and there's a lot of work you've done to make this launch possible. But let's start as high level as possible. What is Amazon IVS?
IVS stands for Interactive Video System, and it's an end-to-end video system intended for live interactive experiences. So if you go to you're on Twitch right now. If you were a broadcaster, you would use OBS typically, but maybe something else. And when you start that broadcast, you hand it off to a video system. It goes across the network, it goes to servers, the servers do things to that video, and it gets it out to the rest of the world. You could build that with a lot of different pieces. You could build it from scratch and build each of those pieces yourself. But however you do it, it's a pile of work. It's years of work and very large team. And what we've done is we've packaged all of that up, essentially the system that powers Twitch today, and turned it into an AWS service, and that's Amazon IVS. It's available today. It's pay as you go. It works as well as Twitch works. So if you like Twitch, if you're happy with Twitch, you will be happy with IVS.
Yeah.
Now, no. Yeah, you mentioned a lot there, that it's a lot of work, and one thing that I really appreciate is not only is it a lot of work, even after all that work, there's no guarantee that the result is actually going to deliver the performance that you want.
Yes, absolutely. We got to be honest. The internet was not designed for live video. Live video is shoehorned onto something that it's not really intended to do. And it requires so much work to deal with all of the problems the real world throws at it. And so if you, as programmers, we all know that, we spend, more of our time dealing with the exceptional case than the happy case, the happy path. But with live video, it's almost all unhappy path. and to learn what all these unhappy paths are, it just takes years of experience. And so, this got started 11 years ago, and it's been year after year of more great people learning how to deal with all of these problems the internet throws at you. And so that's why today, if you go to Twitch, it's like works very reliably. And that's from years of experience.
Yeah, one thing I was going to say, and this is probably something that a lot of folks could use a little refresher on. When we talk about something being vended as a service, maybe we could provide a little context there. So many folks have probably heard of something called cloud computing. This is largely the move from having to manage your own physical data center and your own servers to having another vendor who can do that at scale with high performance like AWS to do that, so you can virtually vend yourself as you want, on demand, pay as you go, a lot of the concepts you just spoke to. Now, if I'm understanding this correctly, IVS, with being the technology that powers Twitch, is essentially the ability for developers to go and build their own platform that looks however they want it to be, to moderate however they want, but with the battle-hardened technology that you've developed at Twitch.
Battle-hardened video technology. Twitch has to deal with, just surprise things that happen. All of a sudden, you have a stream that started off with 10 people and now has 1 million plus people on it, and it happens in seconds. These are things that you don't get good at unless you have to actually fight these battles. And these are the kinds of things that we've built into the system and is available to everybody. And so you can build this for any use case that you see fit. The exciting thing for me is I'm a big fan of live interactive video. I believe in it. I came to Twitch 7 years ago because I had spent almost an entire year obsessing over watching Twitch. And I couldn't figure out why. It's like, what is so cool about a live interactive video experience? And I couldn't put my finger on it, but I knew it was something that was innately human. Humans like to be in the presence of something happening right now. And they like to be able to affect that. They want to be part of that. And Twitch offered that, and it was like, okay, I have to join this. I want to be part of this. And so when I look at this, I think, wow, we now can enable people to build all sorts of other kinds of domains. So think of all the other places on the internet besides gaming where this would be great. And this is what we're hoping to spark, is just a revolution in new things that people would do with this.
Martin, I think you hit the nail on the head. There is something electric about that live human-to-human interaction. I remember the moment for me, I was watching a voice actor for a video game that I loved, and he had a Twitch stream going on with 50 viewers, and he was taking requests. You could post a quote and say this quote in the voice of this character. And I asked him to say something, and he did it. And I was like, wow, that's incredible, right? And I think that's one of the things that makes that live communication, especially on Twitch, really, really powerful. It's the fact that, and we have this going on right now. We have all these people in chat. You can ask questions, by the way. We're not trying to talk at you, right? This is itself a bona fide Twitch stream. We're live. So if you have any questions, we've got the experts on the stage here. let us know what you want to know, and we'll ask them.
One of the things that has surprised me a lot when it comes to sort of this consumers of the Twitch platform, like people who stream, like the content creators, viewers, myself, Robert, Marty, you too, is the amount of the technical side of Twitch that people end up getting to know over the years, even without them being software developers themselves. Things like understanding the latency of when you as a streamer do something and when it shows up to your audience. Like, these are tangible experiences that we all deal with and we interact with, so we appreciate it even if we don't always understand how that sort of happens under the hood. But you said you joined 7 years back. For folks that have been following Twitch's story for a very long time, was it Twitch at that point? Was it still Justin TV? I don't quite remember when the transition happened.
I think it became Twitch, I believe, 9 years ago. Hopefully somebody more knowledgeable will join us and answer that question. I believe I started watching Twitch about a year into Twitch's existence, and then I watched Twitch for a solid year before I said, I have to be part of it. One of the things that we're particularly proud of about this system is how quickly you can integrate it into anything you already have today. We've had people tell us that they had live video up and working in their existing web app or mobile app in less than an hour. And that's just stunning. That is so fast. And that gives you a global reach. It gives you, a managed service. We're watching playback. We're making sure people can watch correctly. We're making sure we'll let you know if your broadcast has problems. We have the information. And we're paying attention. If there's some little problem somewhere on the internet, we're on top of it. We're dealing with it. If one method to get to your audience isn't working, we're on top of it. We're getting to your audience a different way. This is all transparent to you. All you have to do is write a little bit of code, and now you're live.
It's I can attest to that firsthand. The service is generally available now, which means that any folks can sign into their AWS account and start building with it. But I got a little bit of an exclusive sneak peek earlier on. There was an internal hackathon, essentially like a computer programming competition, marathon, what have you, to build cool demos on some of the earlier prototypes or closer to launch of interactive video service. And that I can definitely attest to that. The idea of, this endpoint, this programming interface, essentially, that software developers are used to working with all the time. You can essentially create a stream. You can pass a call to it and get a stream endpoint back with stream keys and create essentially the stream platform almost instantaneously, or the hardest infrastructure that IVS deals with. But I think I would be remiss if I didn't bring into the fold someone who is also very familiar with that hackathon and largely a much broader story that I think we're alluding to here. I'm not going to spill the beans on who it is, but we're going to be right back in just a second, because I want to talk a little bit about the story of, even before IVS was maybe conceptualized, the broader partnership between Twitch and Amazon. So hang tight, everyone. We're going to be right back in just a second. All right, we're back. Same speed as an F1 pit stop. At least I hope it feels that way. We are joined, as a lot of folks can see because they see the overlay here, Emmett Shear, the CEO of Twitch. Emmett, I know you are a very busy person, but thank you for taking the time out to talk with us today and to talk with the community.
Yeah, thank you for having me. It's always exciting to get to chat with people who care about Twitch and want to build cool stuff.
Welcome to the show, Emmett.
Yeah, so we've been talking about IVS, and this is very exciting to us. Rob and I are software developers. We're geeking out over this, and the ideas are floating around with what can be built with this. But I think the story really starts a lot further upstream than the naming of IVS or even vending a service to other developers. This starts with the story of Twitch, and there's no one else that knows that better than you, right? I don't even know how far to go back, so I'm really going to kind of punt it to you. But when did even the ideas of Twitch joining Amazon, the idea of a service to vend Twitch's tech, where do we begin here?
we were talking about whether or not we wanted to sell the underlying video system as a service before the Amazon acquisition. Twitch was started in 2011. We launched the same day of E3 in 2011, and we really spent the first few years just trying to build stuff, just trying to get any traction at all, and growing the gaming service. But within a couple of years, it became clear we built something for our own use that was pretty cool. And after the Amazon acquisition, I became pretty confident at some point we'd want to turn it into an AWS service, because I knew we'd built something really special, something had taken us a lot of effort, and it was time to turn that over. Now, I didn't think it was going to happen actually this quickly. I was a little bit skeptical that we were going to be able to get it done and get it out there as fast as we did, but the team was really enthusiastic about it. I really thought they had something important, and I was very supportive of us giving it a shot. And we've really managed to run down all of the issues and get to the point where we can offer it to everyone. I couldn't be more excited about that.
Yeah, I mean, that seems like such a big sort of like bifurcation, right? Like, building of Twitch, there's so many challenges that come along with that, from on the building of a platform, engaging with your community. Marty was hinting before that there's just so many challenges and edge cases that come up with the tech side. Was there very much like a skunkworks project in the beginning to plan that potential, vending of a service? Like, was it something that lots of people at Twitch would have known about? Like, how did that evolution sort of happen?
In the beginning, it was very much just a small team of people with Marty trying to figure out what to do. But you might have noticed Amazon has Amazon Live. And the interest from the Amazon Live team was actually the very first moment where we were like, oh, we have a customer internally. Somebody wants this. And if we worked with them, maybe they could use it. And so actually, it really started out working with Amazon Live, doing live streaming around shopping and the Amazon experience, and realizing, oh, we've actually built something that other people really could use. It's made a big difference to them. And us having that validation gave us the confidence to keep investing, keep skunk working the project, I suppose, and build it out to the point where we were ready to make the big investment to actually turn it into a full AWS service.
Emmett, so you mentioned that this was an idea that had started even before the acquisition, and then later on you iterated with internal customers. Based on what we're seeing today in the general availability launch and the ideas you had, or that you and the team had way back when, 9 years ago or 7 years ago when Martin joined, what are some of the major changes that have happened? Is what we're seeing today mostly the intact vision, or what are some of the paths that it's taken and some adjustments that you've had to make?
It's pretty much the vision we started with. I would say the biggest thing that we haven't done yet that I hope we get to doing eventually is really giving just even more flexibility around exactly what trade-offs you make for latency. We have a good deal of flexibility there. I think it's a really cool package. But I think we're going to see demand, people who want to be able to do really high quality transcodes or really low quality transcodes, and beyond what we've done. And we decided we'd start with the settings we started with, but I think we'll cover 90% of the use cases, because we didn't know what the 10% would be, and exactly where we'd see what customers' needs were. And we decided it was better to get it out there, see how customers used it, and then iterate from there. But I think we're going to have a whole spectrum of options there over time that we haven't even invented yet.
Yeah, I want to go back to one of the instances you named before, which was after the Amazon acquisition and the use of Amazon Live or AWS Live. a lot of folks may have seen this, but they didn't know that's what it was called. So on Amazon.com, the retail platform, there are oftentimes live video broadcasts for certain products and services. It's almost like the online shopping channel, I guess you could say, where people broadcast stuff like that. And so when you said this was an internal customer, this was more than just MVPs or prototyping. This was the live service on Amazon.com was essentially the test bed for a lot of what became IVS, or what IVS eventually became. It's really cool.
There's so much more we can do with Amazon Live too. I want to make it more like QVC, where we have the 24/7, the infomercial style. Hey, buy a 100-piece Tupperware set, and we'll throw in this, whatever, 100 more pieces.
That's right. Well, I really liked. I don't know if people here saw Twitch Sells Out. One of the events we ran around Prime Day one time was Twitch Sells Out, which was a Twitch style QVC, and it was really fun. I actually really enjoyed watching that programming, and I think a lot of other people did too. And I think we're still at the very beginning of what you can invent with live video. It's just been so hard. It's been so hard to build live video stuff that the next level of innovation on top of that hasn't happened as much, because you just get stuck trying to get it to work at all. And I think IVS is going to unlock a bunch of new use cases. When we looked at where we think usage from live video is going to come from, obviously there's a lot of people doing live video already, and there's a lot of companies and startups that are building live video products, and we think they should be customers. But what I'm most excited about, and what we thought is the really big potential for IVS, is all the things that you couldn't build without having this work done already. And I'm most excited about that. I want to see what people can invent now that it's easy to wire up live video.
Absolutely. I love this comment in chat. AWS has a retail platform. Yes, Amazon is the AWS retail arm. So, it wouldn't be a Twitch show unless we toss some questions at you from chat. Are you okay with that?
Yeah, sure. Let's do it.
Okay, so we have Gene, friend of the show. And if I understand correctly, Gene, you're still at Riot. So Gene does DevRel for Riot. Riot Games, of course, makers of League of Legends and many other awesome games now. At any given time, a significant percentage of Twitch traffic. And I think Gene and a couple of other folks in chat are wondering, what was the thinking behind the pricing structure for IVS? And one of the questions here is, why is the input pricing for standard costs 10 times basic streams? Emmett, can you talk about that?
So to understand that, we kind of have to understand the underlying computation that drives IVS. The really expensive part of taking a stream in is not the bandwidth to pull it in, but the transcoding. Doing high quality transcoding in real time takes a lot of compute. And we dedicate a huge amount of compute to making sure we get great quality transcodes when you send us a stream. But that just costs money. And so there's an intrinsic sort of price associated with doing a standard stream. Basic streams, skip that. You don't get the advantages of having multiple transcode qualities, which is really important for viewers who have lower quality connections, but you do save all the money. We wanted to make that trade-off available to all of the customers. But unfortunately, I think there will always be a cost to doing transcoding well, especially if you want to do it in real time for high quality video.
Yeah, I think we'll drill down on some of those the technical minutia when we bring Marty back on in a little bit. And I one thing to let everyone in the audience know, we're actually going to see a live demo with using IVS in action. So we tell you that it's easy to use, it's easy to get started, but you don't have to take my word for it. You'll hopefully be able to see that in action. We have another question. It's not necessarily IVS related, so but I'll ask it anyway. Zio Delta is wondering, is there any chance of an Alexa skill for Twitch, or like a first-party Alexa integration?
I think that's an interesting question. We've obviously thought about it. We think about how we work with the other groups at Amazon. We haven't yet seen the Alexa skill for Twitch that we've wanted to build and release yet, but it's something we continue to be excited about, and maybe at some point we wind up building an Alexa skill. I think there's a lot of people out there with Alexas, and a lot of those people are increasingly also Twitch customers. So maybe we find some overlap there.
Yeah, another thing I was interested in, it's not necessarily a question on chat here, but having played around with the IVS service myself. It's more than just the video. We were talking with Marty about this tangible nature of like being able to interact in real time, and like syncing that to video content can be really important, right? If you can pass the video along, but people still need to be able to perform all these extra operations, that can be tough. So when I think of things like Twitch, it's like, if an event happens in chat, I want to sync that up with something that happens on my stream. That's really cool. Do you think we can, or developers can expect to get more features along that lines of being able to see like quality of life features that maybe Twitch offers and that people like and may want on other platforms bundled into IVS at some point?
Yeah, our ambition is to continue to improve IVS every year, every month, every week. I think, there's a trade-off as you're building something like IVS, trying to build out the entire complete set of features you'd love to have in theory versus getting something high quality and scalable into the customer's hands now. I think we did a good job picking a trade-off point for that. I think the product does a lot. And for many customers, it's going to be everything they need. But I also think there's a bunch of cool stuff you can do on Twitch. Clips comes to mind as a feature that IVS doesn't yet support, but we'd like for it to support. And over time, I think we'll be layering in more and more of those nice to haves, or sometimes must haves for certain use cases. That's going to expand what you can use IVS for.
At Amazon, we like to say that, or at AWS, we say that 95% of the feature roadmap is driven by customer and user feedback. And I know lots of folks watching may not be software developers, but I think it's important to reiterate, like, the version of IVS, Interactive Video Service, that launches today is just the first step, right? This is not the what people will build on in its current iteration, but it will constantly evolve in response to that feedback. So if something is desired that is not there right now, are you open to that feedback to drive that roadmap as well, to sort of make IVS better for more folks?
I think that's why we launched it when we did. We have a bunch of ideas what we think are probably the best new features to add. But there's nothing like actually having people using the product that to get real insight into what are we going to do, because those people are the ones who are actually in the field, actually using it, and they know way better than we can guess how we can improve IVS. So I'm really excited to start getting that feedback as people begin to use the service.
Yeah, and one of the things I want to revisit briefly is, Marty was mentioning all of the hard work that happens and how all of the edge cases you need to solve to get this experience that people see on twitch.tv today. A lot of that work is very, very detailed, and it's subsurface. And I have a friend who was an early Twitch employee, and he was maybe sharing a little bit more about than he should have shared about just all of the infrastructure challenges that you were dealing with in the early days of Twitch, and just how nuanced it became, how detailed it went. Maybe you can give us just one example of, Marty had talked about you can assemble this thing yourself, but really you're in for a long road if you're going to build one of these. And so really the cost that we were talking about earlier, the fact that it is embedding all of this experience that you've had over the years of building Twitch. Can you give us a sense of one of those deep problems that you've solved at the infrastructure level?
So the thing to understand about the internet, I suppose, is that the image of it you were given if you took a course in college about networking is a lie. There's a sort of idea with the internet is you connect to the internet, and then you send the information out, you send packets, and you address them to the person, and they get delivered, and it all works. And that works to a point for very small amounts of data. If you don't need to have very tight latency requirements, if you don't need very tight deliverability requirements. But the truth is, the internet is a wild west. It's very chaotic, and you can't just buy internet service that delivers your packets reliably, quickly, all over the world. If you want that to happen, if you want to get the video from one side to the other reliably, at some level, you have to shepherd that packet all the way along every pipe it goes down and make sure that there's nothing in the way. And so I think one of the key challenges we solved along the way. This is one of the very first things we worked on, is how the Twitch network talks with other networks, and how we choose to do the routing between the Twitch network, where we have our video coming in to us, and then choosing where do we hand it off to give it to Comcast, or to give it to AT&T, or to give it to an intermediary that's going to hand it off, and how do you know where to put it? And the standard way to solve this problem historically on the internet, how do you set up kind of fixed pathways, and to choose fixed connections, and create systems of heuristics and rules that said, give this packet to this person if it's from this source. And what we did instead is we built a much more flexible system, a software system that could in real time react to network conditions and choose in response to us noticing, oh, there's a degraded connection over here, to route the packets in other ways, and to change how our network connects to the rest of the internet. And that was a big challenge, but fundamentally improved our quality of service. And then it's 1,000 more things like that, little things along the way that enable it to happen. And I'm really grateful to. This isn't my area of expertise, actually. I never been a network engineer. There's a whole set of expertise and depth there. I was really fortunate to have John Shipman on the team build out the original version of the video system, and then Marty and this huge number of other people come in and help build that out, because this was all a learning process for me through Twitch. I had no idea of how complicated the internet actually is before working on it, before getting educated by the team.
Yeah, where folks, the chat got really active all of a sudden. I think Rob dropped from the call. Rob, are you still here? Oh, there we go. All right, Emmett, we're going to have you disable and re-enable video really quickly so that Rob is not moonlighting under your job title over there.
Is that better?
Oh, yeah, you're good. Yeah, Rob's internet dropped for just a moment locally. People are saying you started looking different after you moved over. But yeah, no, the internet is an unforgiving beast at times. A little bit unrelated, but to the same point of these like large challenges that push the boundaries of anyone that's come before you. I was reading this book about I think it was World of Warcraft, the developer diaries. It's a game I grew up on, and that game has changed a lot. But I remember back then you installed the game with 7 CDs, and they all went into your computer, and you had to swap them out over hours and hours and hours. And in reading this developer diary book, in the beginning, they open and say that at a certain point in time, I think before YouTube, that game's traffic and players comprised some obscene percent of traffic on the internet, like 40% or something at peak hours. And so that made like the internet almost at a certain point was that was the biggest thing from a networking infrastructure perspective on the internet. And then YouTube comes out and on-demand video, and I think that something we're all finding today, something like live, like video streaming, whether that's on demand with something like Netflix or live video like Twitch, has become that new big infrastructure challenge. And in many ways, you were the pioneers. And Twitch had to pioneer that. There's no book you could open and be like, yes, let's do it how they did it. Were there any, I don't know, the extent of weird stories you can share, but were there any really funny gotcha moments where you expected something to work in a certain way and it just happened, you just happened to be like, oh wow, I had no idea that was a bandwidth or a constraint or something?
I got it. We hit every constraint it was possible to hit, right? I think the biggest surprise to me was learning that ISPs had just limited total edge bandwidth, and it was possible to simply overwhelm an ISP's ability to ingest the video. Like you could just get to the point where that entire ISP's inbound pipe is filled, and there's sorry, you're not going any farther there without figuring out some way to literally grow the size of the network. And sort of because the internet, I think when you're pushing less bandwidth, the internet feels it's so infinite in capacity. It's like I think the same way you go out in the ocean, it feels like the ocean is infinite. It's not really infinite. It's just very, very large. And it feels like if you poured a cup of water in the ocean, you could pour infinite cups of water in the ocean, and it would never you couldn't possibly change the ocean. But it turns out if you poured enough water to the ocean, of course, you could raise it. And in the same way, if you put enough bandwidth out there, you find out the internet's very much finite. It's very much, it's got edges, it's got capacity limits, and you start hitting every single one of them. And I think that was very surprising when you started actually to hit those limits. And it's been cool to see the team work around them.
Now, when you say that you hit those limits, did you hit those limits as Twitch, or did you start experiencing some of those when it was still just in TV? As in, did you kind of ease into this, or were these things just kind of hit you like a wall?
You hit more and more the bigger you get. So we hit some of them as just in TV. We hit more of them as Twitch. We hit more of them this year. Like just this year, you start to run into new problems as we get to greater and greater scale. Especially when we were smaller, often we'd be in the situation where other people would have CDNs larger than ours. And so if we ran into trouble, we could kind of hit the escape hatch and try to go to a third party and maybe buy distribution from them. As we've gotten bigger and bigger, that's just not an option. We can't go buy from a third party because the third parties don't have any more bandwidth than we do. And so we really start hitting capacity limits. We've got to figure out how to actually solve the underlying problem. And that's a little scary because it means it's up to you to fix it. But it's also been very empowering to realize that we can do this. We can build a network that is large enough that it really can accommodate for all these customers and all these peak usage. I have to run in a second, unfortunately, but I think you probably have time for one more question.
All right, yeah. Looking through chat right now, nothing's jumping out, but largely, I guess, given that this is the last question, let's do something a little forward-looking, right? If you could imagine, and this is like Amazon PR FAQ style writing, I suppose, but if you could imagine IVS 10 years from now, right? Like if you could have a mission statement for anybody that this service can do something for, what would that be? What do you aspire for it to be?
So IVS is meant to let everyone else do what we got to do at Twitch by the good fortune of being able to raise enough money, have the right technical bandwidth, be in the right place at the right time to build out our own video network, to remove that barrier and let people all over the internet innovate with video, whatever they can imagine. And so I think, if I had a 10-year statement, it would be to radically simplify anything involving video and interaction into something where the part that the customer has to solve, that the IVS customer, the developer has to solve, is the new part. And people are no longer resolving how do you stream video, how do you archive video, how do you pipe interactions around, how do you clip a piece of a video, how do you take a uploaded video and add it to a live streamed video. Like, those are solved problems that have been solved dozens of times by companies around the world, but they haven't been solved generally. And we want to build something that lets a developer build whatever they can invent. And right now, I think if what you want, you can have it in any color as long as it's black. If what you want is a live video streaming solution for putting in live video in and taking it out, we've got you. Like, to a lot of people with the latency requirements we have made that radically simpler, and it's something that anyone around the world can use. But there's so many more video use cases that doesn't necessarily address. And I think there's an opportunity for us to make all of those just as radically simple.
You've got a lot of viewers in chat right now. Is there anything you want to tell them before you have to head out?
Thanks for dropping by, and I think we've got some awesome programming for you. You're going to get to see IVS in action and get to dive into some of the technical details. So I hope everyone here is as nerdy as I am, and you're going to get to dive in and really enjoy it.
Awesome. Emmett, thank you again. It's been a real pleasure having you on. Again, Emmett Shear, CEO of Twitch, jumping on show here for AWS What's Next, talking about Amazon IVS. So we're going to go back to a quick holding screen, and we'll be back with Marty Hess to talk a little bit more about the nuts and bolts of what it means to make IVS as powerful as it is. Stick around. We'll be right back. All right, we are back. Connection issues solved. Marty was on previously. I've seen a lot of folks in chat, but also a lot of new names. So we just heard from Emmett about a little bit of the story of the Twitch and Amazon relationship and where IVS can go going forward. And to recap a little bit, Marty, you kicked things off telling us sort of the fundamentals of IVS. But after hearing Emmett talk, I've got a lot of questions that I'm going to now throw to you. So Emmett's written checks that you're going to have to cash, but I hope you're okay with that.
I'm used to that.
Awesome. So yeah, as GM of IVS, you are intimately familiar with the nuts and bolts of sort of how this service works. So very happy to get to follow up on some of these questions here. I actually wanted to give a quick shout out to a lot of the folks in chat. Emmett was talking a lot about how there are so many technical challenges that Twitch has had to address in building not only the platform, but now IVS as a service. And that work wouldn't be possible without a lot of those little wrenches that I see in chat, right? A lot of the engineering folks over at Twitch.
Yes, we have an amazing team. They're very committed. In general, we're a bunch of Twitch fans, so we consume our product every single day. We're passionate about quality. We're passionate about latency. We're passionate about having great user experience. In general, we kind of attract people who want to see the platform improve, often for their own benefit, because they're Twitch fans.
Yeah, on the topic of quality of the platform and quality of life features, like we were talking about with Emmett, we went through some of the. Actually, we may have spoken about this with you as well, but like the ephemeral experiences that we knew we loved live video. And I had been a follower for a very long time on Twitch. I'd streamed every once in a while, but sort of the live interaction was something that really got me. And the culture that can develop from simply just having real-time chat, low latency chat. Folks have been asking, in chat stuff about integrations or use with sports and stuff. And I think one of the funniest scenarios that I really was taken aback by was when I was watching, I think it was the NFL Thursday Night Football on Twitch, something I typically would never watch on TV, but there was just something about seeing, like vac spam in chat or like PogChamp whenever someone made an amazing catch that really emanated. And, like as soon as the catch happens, you look in chat and it's right there. It's lined up right away. There's no like 3-second delay. So, when Emmett was saying, 10 years forward, there's the ability to just make all of that simpler. We don't think about maybe Thursday Night Football and Twitch chat being going arm in arm, but going forward, maybe that'll be the case, right?
Possibly. It's hard to know. Traditionally, it's been divided up between lean back and lean forward experiences. So lean back is, you're in the couch, you're lean back, you're consuming, you're just watching it. And you can imagine a lot of things where you want it to be lean back. You don't want the distraction of a community. Maybe, a premiere of a new movie, Game of Thrones, something like that. But then there's other things where they're just innately a community experience. Certainly sports. People, if they don't have people at their home to watch sports with, they'll go to a bar to watch sports with people. So you can imagine a lot of different things where community matters a lot. And I could see people using IVS for those community kinds of domains. But then there's other areas where, you could say like news, education. These are all areas where you could see where community would really be beneficial. And I think we haven't figured out where that line is. We don't know yet. And I think the main reason we don't know yet is it's just been so ridiculously hard to get to the point where you could just have the video. Now you can have it in an hour, and you can really focus on your ideas. You can focus on your content. You can focus on your engagement, your interactivity. You can focus on the things that make your ideas special and unique for the audience that you're looking to build.
Yeah, and one of the things that occurs to me is the video is one component of it. there's so much other stuff, like you mentioned, there's the community aspect, but then there's all these amazing integrations. And I see so much innovation around this space. Just to give you an example, there's a game called Vermintide, where, it's this 4-player co-op survival shooter. But there's a Twitch integration that allows Twitch chat to make the game harder or easier for the streamers. The Twitch chat, if they don't like the streamer, they can summon waves of monsters to make the gameplay even more stressful.
Yeah, Hunger Games style. Yeah.
And so it's these kinds of really creative loops that happen that I can't wait to. I think we're just scratching the surface.
I agree. I don't even think, the only thing that we know for sure is kind of a universal is chat. But beyond that, it's just the wild, wild west. And Twitch is certainly doing a lot of experimentation, trying things out. And I can't wait to see when many people are all able to go their own directions and try things out. And we'll discover, other ways that communities can be built around live video experiences that I make no pretense that I know how it's going to turn out. I'm sitting here handing people a tool, and I'm sitting with bated breath waiting to see what people do.
Yeah. Well, so speaking of these integrations, would this be a good time to start transitioning and talking about the developer experience, the SDK for IVS?
Yes, absolutely. It's always, from the get-go, we wanted to hide the complexity. It's very easy to expose complexity. It's much harder to hide it. And so it really is, we've seen people integrate in under an hour. In fact, I saw a YouTube video yesterday where somebody not only built a video app using IVS from scratch, but they also added, using various AWS services, chat and user login and authentication. And it was like, holy cow, he did all, it wasn't even an hour, it was like 45 minutes. So that shows that AWS is doing the right things. We're providing people the right building blocks, and people are getting it on how to use those building blocks to create visions rapidly. So anyway, we should probably go to Max, because Max has a great demo.
Awesome. So Max, we're actually gonna show a demo of IVS here. We have another guest on the line who we'll introduce in just a moment. But we will be right back, and then we will have that demo for you in just a moment. So hang tight. We'll see you in a second. All right, so we have yet another face joining us here on the show. We're playing musical chairs here with all the guests here in the third slot. But the most exciting part about this section is, Max, you are going to show us what it means to build with IVS in action. And if you're a developer, this is what it's going to look like to actually get hands-on with it. But before we get into that demo, why don't you tell us a little bit about what you do over at Twitch?
Yeah, sure. First of all, thanks so much for having me. I'm a product manager here on the Amazon IVS team. Basically, I've been working for the past 2 years on building out this service and talking to customers and making sure that we're building the right thing.
Wonderful.
Welcome to the show, Max.
Yeah, welcome.
Thank you.
So we've got lots of very excited wrenches in the audience, lots of other developers in chat watching along from home. They're curious what it looks like to build with IVS. We've heard Marty and Emmett, now they've all said, in under an hour, you can build essentially your own platform without worrying about the heavy lifting of video. Is that what you're going to show us today, or at least sort of how to get partially there?
Absolutely. We're going to get there, and it's not even going to take us an hour. So in this demo, I'm going to show you how to build a quiz app. And it should only take us a couple minutes, actually.
All right. Well, that's a big promise. I won't hold you to it, but I'm holding my breath because I want to see it myself.
Cool. Let's get into it then. So the first step is just navigating to the Amazon IVS console page and actually creating your channel. So I will create a channel and I'll call it just demo, and I will leave the configuration as is. And now we have a channel. And so now that our channel has been created, we can stream to this channel. And you can use just about any encoder that supports RTMPS. But for this demo, I'm going to use OBS, which I'm sure many of you are familiar with from your time streaming on Twitch. So to configure OBS, what you need to do is take the ingest server and the stream key and paste it into the settings panel. So I already have the ingest server in OBS, but I will plug in my stream key. And here I just have some sample content on loop, and I'll press the start streaming button. You'll know you're live when this little green indicator appears. And if we head back over to the console page, we should see a live preview. There we are. So that's our stream. And just to give you a sense of the latency here, if I can arrange my windows, I'm going to move this little icon around. And just about, I don't know, 2 or 3 seconds later, we see that moving over here. And so that's the ultra low latency that Marty and Emmett were talking about. And it's really, that's really key to enabling this two-way interactive type of experiences that we're looking for. So at this stage, we actually have a stream, a live stream up and running. You could take the player SDK, you could plug it into your website, you could plug it into your mobile app, and you'd be done. And I think we're probably about a minute or two in here. But I want to show you one of the cooler features of the service called timed metadata. And timed metadata allows you to synchronize interactive elements with the video stream. So in the case of a quiz app, for example, you want the questions to appear in sync as the host is reading them. So we've prepared a very basic quiz demo here. It's just a basic web app. It uses the IVS Player SDK, and it has a quiz UI built on top of it. So the first thing I'll do is I will go back to the console page. I'll get our playback URL, and I'll plug it into our player. Awesome. So now that we have our stream running, the next step is actually sending the questions.
Wait,
and
hold on. Sorry, I know I'm interrupting, and this train is moving at 1,000,000 miles an hour. Like, there's so much I want to say, but you know, that first part, the 1 to 2 minutes where we saw the preview in the console, you literally created this stream channel, which you could then do over an SDK call, so automate that and instantly return a set of stream credentials to anybody, and then just pop those in and start streaming.
That's exactly right. So you can create thousands. You can create as many channels as you need. They're instantly available. People can stream to them, and those streams are available instantly. And that video you could then distribute all around the world.
That's awesome. So like every time someone signs up on your platform, you can just run that call, and then they have their own personalized stream channel.
Exactly.
Wow. And you're going into it right here with the events, but I wanted to touch on something that you glanced over very quickly, but is actually really impressive. This player is essentially like, that's another thing that people would have to work on or use their own libraries to build their own player that can then integrate and ingest the stream that you're passing to the front end. But more than handling that video piping, IVS actually gives you an SDK for the player all in one. So it is like a complete white glove experience, right?
Yeah, absolutely. So with IVS, basically, all you have to do is send us the video and we take care of the rest. And that includes playback as well. So we have player SDKs for iOS, Android, and the web. They're super simple SDKs. You can see here some of the JavaScript for the player SDK. You just drop in a script tag, or we have an NPM module if you would prefer. It's the player is tailor built to play back the IVS streams. And so you don't need to deal with finding players or configuring players for all the various platforms. We provide that piece as well.
One thing I was going to call out that a lot of folks just sort of are used to as like table stakes on Twitch is the player's ability to, switch the quality of the stream as a viewer, right? Maybe your bandwidth isn't so hot or network outage, network's not doing well. You can switch between those qualities. Usually the developer would have to manage all of that, but the SDK for IVS, I'm pretty sure that has that bundled in, right? So that capability, they can switch between the different video qualities.
Yeah, that's exactly right. So if you set up your channel as a standard broadcast, which we talked about a little earlier, we'll generate a set of qualities, and then the player will switch to the optimal quality for each viewer based on their network connection. So you might have viewers that are on a really strong and stable network that can watch full HD, and you might have a set of viewers that are watching perhaps from a mobile network or just a constrained network or unstable network that can only watch 480p. And the player has all that decisioning logic built into it, so it'll pick the right quality for each viewer.
Okay, wonderful. Sorry, I did not mean to interrupt, but back to timed metadata or timed events. I didn't mean to derail us, but there was just so much in there that I thought deserved to be mentioned.
Cool. Yeah, absolutely. So again, where we are right now is we have our stream up and running. It's live. We have a very basic web app here, which is built on the JavaScript player SDK and has a simple quiz UI on top of it. And we plugged in our playback URL from the console into this player. The next step in building a quiz app is we need a way to send the questions in sync with the video. So as I said before, what's really important often in interactive experiences is having a interactive element that is in sync with the video, regardless of each viewer's latency. So in the case of a quiz show, you have a host reading a question, and you want the question prompt to appear as the host is reading it. And that's what the timed metadata feature enables. So I'll go ahead and send a question here. And the way that we'll do this is we have a very basic API, the put metadata API, that takes a payload of just arbitrary data. In this case, I have a payload, which is a question and a set of answers. And we'll use the AWS CLI to call this API. So what will happen when, one last step. So each channel has a channel ARN, and this channel ARN is essentially the unique identifier for this channel. So because this channel is new, I didn't have the channel ARN here. I'll go ahead and plug this in. And what will happen when I call this endpoint is the question will get carried alongside the video to each viewer. And then if we go back to the player code here, the player will parse each question as it receives it, and it will trigger the quiz UI. So I'll go ahead and switch this to a full page view. Actually, I'll save this. We'll switch this to a full page view so you can see the questions as they come in. And we will take the put metadata command and go ahead and send this. So what we should see is a few seconds later, based on my latency, we'll see the question. So just some Twitch trivia for you all. And actually, I might have answered this before. When did Twitch launch? Rob or Nick, do you remember earlier from the conversation?
Yeah, 2011 is my final answer.
Yeah.
Correct.
Awesome.
What do I win?
You win congratulations.
You win a sticker. Hold on, I've got it for you. Give me 1 second.
Oh yes.
How does this one look? Fans of that.
Wait, I have that chat. One already.
you
Max, can you take us back to the code for just 1 second?
Yeah, absolutely.
So if I understand correctly, this is coming in from that metadata call that there was somewhere, yeah, right there, the player event type text metadata queue. Is that where this is happening? You have a callback function there?
Yes, exactly. So as I said before, when you send metadata, it gets carried alongside the video as part of the video stream itself. And then every time the player sees metadata in the stream, it fires this text metadata queue event. And then it's up to you to take that metadata and to trigger whatever interactive experience that you're building. So in this case, we're taking that metadata and we are triggering the quiz UI.
Okay, so just wanted to summarize this for both my benefit and for the benefit of the audience. We don't have to build a quiz here. We can actually send arbitrary payloads of data that will trigger the metadata callback, and then we can handle that in whatever way we want. So for instance, one of the things we can have in the payload is like interaction type, and we can build multiple kinds of interactions, whether it be a quiz or a survey or really anything, right?
Yeah, totally. The possibilities are endless. We see a lot of customers that are building live commerce use cases where they're sending SKU information as part of the video stream, so that when a host is talking about a particular item, that item appears as kind of a byte, now call to action. There are a lot of different possibilities. It's, as I said, it's an arbitrary field of data, and you can sort of do with it what you want. But what's important is that we do the hard work of actually syncing that metadata with the video.
So aside from the metadata API that we have here, could you point out some of the other major API endpoints that we have with the SDK?
Yeah, I mean, the SDK is pretty straightforward. It's quite simple. The way it works is, at least on web, you just drop in this JavaScript, you tell it what the playback URL is, and you call play. And that's really all we had to do for this demo. If you go to the Amazon IVS documentation, you can see a full set of reference docs for the player. But really, to get up and running, you don't actually need to do all that much with the player, and that's very much intentional.
Mm-hmm. Is there any ability to customize the look and feel of the scrubber or the frame around this thing?
Yeah, absolutely. So that is all fully customizable. And actually on the web, we provide a plugin for Video.js, which is one of the more common player frameworks that has a lot of customization ability built in, and also a whole community of freely available skins.
Awesome. And then, okay, final question. I promise. I feel like I'm taking up a lot of time, but one of the really cool things that I see the Twitch community doing all the time is taking clips of moments that they want to save and share. If we wanted to build an experience like that, is that supported right now, or how would that work?
It's absolutely possible if you use some other tools within AWS. It's not something that we natively support today, but it's feedback that we've heard from many customers, and it's something that we're considering supporting built into the service.
Awesome.
Wonderful. I mean, we heard before that 1 hour is the amount of time it can take to get up and started, but you showed us quite literally in just a few minutes. I think that for those that are used to working with boilerplate code, I see here you have this code pen. Are there resources, like essentially what I saw you do is paste your unique resource in here, and it just worked with this boilerplate code. Is an example or a code sample like this something that folks could be on the lookout for to implement on their own?
Yeah, absolutely. So first of all, for those here, if you missed something, you can head over to the AWS blog. There's a post from July 15th that walks through this demo in much greater detail. So you'll find all of the code that I've shown in this demo is referenced here in this blog. Additionally, we have code samples on GitHub as part of the AWS samples organization. So we have code samples for across all platforms, and you'll find this demo there as well. Also, the same demo on iOS and Android, additionally.
Awesome. The gears are turning in my head for experiences I could try to build using this new service. But in the more immediate future, I'm currently streaming on Twitch, so I figured that we can probably move things along in just a moment. Chat, I know there's lots of you, there's been lots of chatter, but before we move off of this segment, I want to make sure that all of the comments on IVS or questions are answered. So if you have, we have a question for a link for the blog, so I'll go and hunt that down. But again, if whether you're a developer, whether you're not a developer, is there anything you want to know a little bit about the tech that powers Twitch, anything about interactive video service, please let us know as we sort of close out this first section.
Yeah, seriously, chat, this is some amazing stuff. It's dangerous for me personally because I have a day job, but I already know that my afternoon is going to be spent hacking on this. So if you have any more questions, now is the time. We have all the experts on stream. Let us know what you want to know.
people wondering if C++ is used at Twitch. I'm so thankful we have Twitch staff jumping in, answering our questions, making it easier for our guests too. But the answer to that being yes on the video playback team. We have some links in chat there for the blog post. Someone also wondering if IVS is available in the free tier. So for people that may not be familiar on AWS, if you want to get started with some of our services, there is a threshold of usage that you can use them for free. Typically, that's a certain amount of usage per month or something. And IVS, I think Rob said it is free tier eligible.
Yeah,
Yes,
that's right.
that's
I believe when you create an AWS account, you get something like 5 hours of standard video included per month, and then 100 hours. So 5 hours of HD and then 100 hours of standard.
Yeah, you definitely.
Fact check me on that.
I don't know if that's exactly correct. I believe that you get basic channels, but it's more than enough to get up and running and try the service.
Wonderful. Lots of folks asking for a link to the broadcast. We're going to be this video will have a VOD by default, and we'll have links on our own socials and so on. If you're interested in seeing this again, we'll also re-upload it elsewhere. If you're following AWS, follow myself, follow Rob. We'll definitely be tweeting all those things out. But without further ado, Rob, anything else you think we should cover or touch on with IVS before we move on to the second session for today?
Yeah, I think there's a quick question we can knock out. Top Swag Code asks, ASP.NET Core 3.1 support. I assume you are not talking about Blazor. You're talking about serving a website that from ASP.NET Core that supports IVS. And the answer is absolutely. What we're seeing here is CodePen. So imagine that you're building you're serving a single page app, or even server-side rendered, right? And you can include the script and it'll work in the front end. The browser will be none the wiser that you're using, .NET, PHP, whatever.
I've got another question in chat from Onyx Raven. They're wondering if IVS will integrate with things like Kinesis video streams or do other sort of like quality of life amendments and processing on that video stream. So an example they have here would be like object detection. Imagine something like Amazon recognition or translation or transcription. Are these quality of life tie-ins that users could see in the roadmap in the future for IVS?
Yeah, that's a really great question. So you could absolutely use IVS with other AWS services. IVS itself, we like to say it's kind of a bigger building block than most AWS services themselves, but it does fit within the broader set of puzzle pieces that AWS provides. So you could certainly wire up IVS with Kinesis Video or Recognition or any other AWS service if your use case requires it.
Wonderful. I feel bad because I'm giving IVS so much coverage here, but given the relationship to Twitch and the audience and how much it affects them, this launch is just so unique in so many ways, right? Most of our launches, sort of by nature here at AWS, will be most exciting to developers that will use them. But I think that with us as developers that create these experiences, we also use them ourselves so much where we're here streaming on Twitch ourselves, right? We consume Twitch, we watch all these different shows on it. So even if you're not, let's say, a developer there watching in the audience right now, these services and understanding sort of the functionalities that they enable will sort of pave the way for the platforms that are going to pop up as a result of this, that new experiences. We mentioned before that we can't even imagine, Marty can't even imagine how all the ways that this will be used. Like, I'm personally holding out for the hooks and integrations where we have truly community driven games. We had Twitch Plays Pokemon with like hacked emulators and Twitch chat and stuff. But imagine like a choose your own adventure game that's just completely built from the ground up with IVS, where you just go to a web page. Like, that's what the future could hold, and that's really exciting to me. And I know that everyone is probably imagining an equally as exciting scenario that looks slightly different. Cool. So sorry, I just went on a soapbox for a little bit about how excited I am. My mouth is hurting from smiling, and people were teasing me in chat about that before, that I was excited and geeking out when you were working through the console. More than anything, I was just anxious you were going to leak your stream key, which I think is something that...
Oh no, I practiced. I practiced that.
Yeah, we've all made that mistake.
Yep.
I think in the case of Nick and I, probably dozens of times a year. So it's just always feel a little bit better when other people mess up. Just
yeah,
give us a little slack here.
Been the fatal error for sure.
Yeah. And I mean, just to touch on what Nick said, part of the reason we're so happy about this is because we're Twitch viewers. We use Twitch all day, and just seeing the evolution and seeing what the service can do and seeing how easy it is. I mean, the gears are turning for us. I can tell you for sure how we are going to be using this in our projects, whether it's hobby projects or work projects. I mean, I really feel like this has opened up a lot of possibilities.
Yeah, that's really awesome. As Marty said before, many of us are fans of Twitch and fans of interactive video in general. And so we couldn't be more excited to see what people build with it.
Final comment, which again, looking forward, if folks in the audience are developers, they're interested in using this. Marty said, he can't imagine all of the ways this will be used, but the reason why this was released now was so that we can continue to develop this together with community feature requests. What would be the best way for folks to reach out or express their desire for certain features in IVS?
Yeah, so we are very active on the Amazon IVS AWS forum. So if you go to the AWS forums, there's a specific section for Amazon IVS, and I can tell you that the team actively watches that, and we'd really love to hear from developers that are building products on the service, and we'd love to hear your feedback.
Wonderful. And Rob and I were trying our best to describe what a developer advocate does briefly, but that's a high challenge. But broadly, we also serve as conduits for some of that feedback. So if you find us on social media, you let us know some of those feature requests. We will do our best to get that passed along to the service teams, just like we see right here. So cool. Well, without further ado, yeah, we have our social links in chat, link to the forums in chat. Man, such an attentive audience today. This is wonderful. We love to see it. We are an hour and 15 into the show, and we have 2 other sessions left, but we could spend all day on IVS. Honestly, this is so cool. And I think that, it seems like even in the audience, folks that may not be developers are starting to come to the same conclusions we are and see really what is possible here. And that is due in no small part to, this demo that you provided, Emmett getting up here and talking sort of about the vision and the history of it, and Marty walking us through the background and some of the technical nuts and bolts that went into putting this together. So, thank you to all of you folks for taking the time and coming out onto the stream today.
Thanks so much for having us. We're really excited to be here.
Awesome. Well, without further ado, the show must go on. We will be right back. When we return from the break, we will have a demo from or a session on DeepRacer Evo, an autonomous driving vehicle that you can train your own model. And there's been some really interesting updates that I think you're all going to love to see. So stick around. We'll be back in just a few moments. All right, we are back again here with AWS What's Next, the show where we cover the latest launches from Amazon Web Services. We just had a very exciting session on Amazon Interactive Video Service, but switching gears a little bit, no pun intended, we're talking a little bit about AWS DeepRacer, which we will cover in just a moment. Before we get into that, joining us here, fresh faced on the show, Eddie Kaleha, if I'm pronouncing that correctly. Eddie, thank you for joining us. And as a senior software engineer here at Amazon, I know you are closely familiar with the DeepRacer itself. But why don't you tell folks sort of your relation to this service? That's very exciting.
Yep. So I've been on DeepRacer pretty much since its inception. And today I oversee the software stacks for the virtual environment, the reinforcement learning algorithms, and the device software, which is what we're going to be talking about here today.
That's awesome. Welcome to the show, Eddie.
Well, thank you, Robert.
Yeah, I'm chock full of puns today. So switching gears and now driving right along. We're here to talk about DeepRacer Evo, which is an exciting new change or an improvement, new set of features. We'll talk specifics, but my point being here, let's talk a little bit broadly about what DeepRacer is, because I know that there are many enthusiasts who are very aware of what it is. But for folks who have not seen it at all, Eddie, can you give us a brief rundown on DeepRacer?
Yeah, absolutely. DeepRacer is a 1/18 scale autonomous driving RC vehicle, which launched at reInvent 2018. And we really built it because we wanted to sort of onboard people with reinforcement learning and make it the fastest way to teach folks about reinforcement learning. And so we built out the platform in two parts. We have a virtual environment where you can go train your models virtually. And then we have a physical device where you take those models that you trained in the virtual environment and you deploy them down onto the physical device. And sort of while we were developing DeepRacer back in 2018, we were kind of having challenges between the groups. So, it was like the engineering group would challenge the science team. And out of that kind of was born the idea of having the DeepRacer League, which I know we'll talk about in a little bit. But this was sort of a way to see who had the best models, so to speak, and sort of compete. And so we brought that to customers as well back in the initial launch of DeepRacer.
Now, Eddie, you mentioned that this is meant as an introductory experience for reinforcement learning. Can you talk a little bit more about that? Let's say, we have somebody who gets started with DeepRacer and gets really hooked on reinforcement learning. How can they expand upon that within AWS?
Well, we have lots of great learning resources if they want to learn more about reinforcement learning, and I'm sure some of the moderators will put that in the chat. But if they want to go further than DeepRacer, it works actually on two other AWS platforms, AWS RoboMaker and AWS SageMaker. So once you start getting comfortable with reinforcement learning, you can go over to AWS SageMaker RL and start building out more reinforcement learning models there and continue to grow your knowledge and actually leverage reinforcement learning for whatever your production use may be.
Yeah, I was going to say, when folks think reinforcement learning, for anyone who's had a cursory introduction to machine learning and AI, reinforcement learning can be this thing that's very scary at first glance. But there's just something about being able to test your model. Oh, Rob's video dropped. He's back. Eddie, when you get the chance, just disable and re-enable your video and everything will be back again. But I was just going to say, reinforcement learning can be scary, but DeepRacer makes it easy to sort of understand the behavior of your model because you're quite literally having your car drive as a result of the model that you've loaded onto it, right? So you get this very tangible experience of like tying real world phenomena to this model that you've trained, and there's just something very real about that interaction that I think helps a lot of people really start to understand the concepts at play here.
Yeah, absolutely. And if I may just add to that, one of the things that differentiates reinforcement learning from like traditional machine learning techniques is this sort of idea of thinking about incentivizing behavior. Whereas, in regular machine learning, it's sort of like, hey, you just want to train this thing to, for example, and this is a joke I'm sure I'll use over and over again throughout the broadcast, but like a cat dog detector, which is something that, when we all learn about machine learning, this is like one of the first things we do. And then all it can do is really, hey, tell you if something's a cat or a dog. But in reinforcement learning, it's really learn the behavior. And one of the cool things that you can do is, hey, I trained this car to drive a particular track. And then I can go, so say, for example, the Barcelona track. And then I can go and see how it performs on like the reInvent track. So that is super cool. It really learned the behavior of how to drive and what to do and what sort of actions to take. And thinking about that is really an exciting part of reinforcement learning.
So, yeah, definitely. But on the topic of what other problems it can solve, you mentioned the cat dog detector as an academic example. Can you just give us some other real world examples that reinforcement learning is best situated to solve?
Yep, and just a quick correction, Robert. So reinforcement learning won't really do very well with the cat, more like supervised learning. But reinforcement learning is used, like for example, to manage like the temperature at data centers where temperature is really critical. And normally this is managed by something called the PID, but a reinforcement learning algorithm can basically, you can incentivize it to make it warmer or colder depending on what target temperature you want. And it's also used sort of in the financial sector. It turns out that whenever you have something that requires a strategy, reinforcement learning is a very good tool. And if you just go and Google on the internet, you'll see reinforcement learning. People usually benchmark it against video games because, again, there's this sort of like strategy concept in video games of like, hey, which sort of way do I want to solve the maze, or how do I get the most points, that sort of stuff. Reinforcement learning is really good at solving those type of problems, as it does with AWS DeepRacer, where the strategy is, hey, how do I get around the track the fastest?
Yeah. Chat is astutely paying attention here. Rob falls off the video call every once in a while and comes in, but the title, the names and titles will be slightly off, but everyone who's been here since the start of the session will know who's who. So we'll leave it as is.
Sorry, folks. I think this just kind of is a testament to how difficult live video is. As you saw from the previous segment, we're experiencing some technical difficulties. Please bear with us.
Yeah, Eddie, while I ask the next question, if you get the chance to disable and re-enable video, that it'll fix it again. Hopefully this doesn't keep hounding us. Lots of moving parts in live video. Go ahead, Rob.
So Eddie, yeah, let me just play that back to you very quickly and make sure I got it all. So DeepRacer here, basically giving newcomers and veterans alike a way to kind of get their hands on a solution or a scenario where the concepts of reinforcement learning are made very fun, very visceral. You get immediate feedback about, and a goal to drive your incentive to learn these things. And then once you have those foundations, then you can broaden out to using the underlying foundational AWS services, RoboMaker and SageMaker. Use those tools to solve lots of different kinds of real world problems, including controlling temperature for various industrial HVAC systems, financial models, etc. Is that right?
Yeah, you can definitely go and expand and build on those services. I would say you probably use RoboMaker more for like your robotics needs and sort of like for a virtual environment, which is what we use it for. We run Gazebo, and that's the virtual simulator that we use to simulate racing around a track. And SageMaker, it's just a fantastic platform. It's Amazon's all-stop, all-shop machine learning platform, and you can build pretty much any machine learning algorithm on SageMaker. So it's absolutely fantastic. Like I said, DeepRacer runs on both of these wonderful platforms, and it's how we bring it to you.
Awesome. I wanted to touch on Gazebo there really quickly. So we won't go too deep onto the fundamentals of machine learning 101. That could take us so much time. But using the simulator to train your model, but also to be able to do that racing and competing. You mentioned before the ability to race around these different named tracks, Barcelona, New York, Las Vegas, for example. The virtual side of this is the DeepRacer League, where when folks want to compete, they can actually compete digitally against one another. And this is something that we've had for at least the past year from my familiarity with it. And to tie this all into where the goals are and what the competition is really about, it was this old goal of being able to make it around the track as quickly as possible. This is racing 101, right? But we're here to talk about DeepRacer Evo, and I know there are some new changes that make this entire competition a little bit more exciting. I figured I'd let you sort of share what's new here as the person who was on the team that built it.
Well, so with DeepRacer Evo, we wanted to sort of let the DeepRacer solve more complicated problems, and that means more complex environments. And in order to do that, if you think about it, when we launched the initial DeepRacer, all it could do was kind of see. You think of yourself, you can see, and that's one sense. But if we want to solve more complicated problems, we got to give it some other senses. And the technical term for this is increasing the state. But really, it's just we added the ability for it to learn how far away things are, and to learn how far away things are sort of around it. And this helps us support more complex environments. So how did we do that? Well, the first thing we did is we added an extra camera module, and this created essentially a stereo camera. And this works just the same way that your eyes work, right? We have two eyes. This is how we do depth perception. Your brain does it a little different than the DeepRacer would, as you can imagine. And so that allows us to know how far away something is, and that information can get encoded into the machine learning model. And then we added a LiDAR, which LiDAR, what it does is it uses lasers to determine how far away things are around it. And you'll see later in the demo that it's always spinning. That's because it's taking data all around its surroundings. And then it kind of tells you whether, hey, there's an object here on my right and how far away it is, or there's nothing there. And so adding these two components and having these two sensors really allow us to expand the AWS DeepRacer. And it allows us to do fun events like the F1 event. And if folks don't know what that is, they can go check it out at aws.amazon.com DeepRacer F1, and I'm sure there'll be a link provided to that in the chat as well. Where we at the end of the day, we sort of took racing strategies from professional racers and then raced them against or top developers up on the leaderboards, and then raced them all against each other. And having sort of these extra sensors and the ability to train in these extra formats, which we're going to get into here in a second, is really what the DeepRacer Evo is about. And so we actually enabled that on the virtual environment at reInvent 2019, and people could get started working on those models right away. And they did. We have such competitive people up on our leaderboards. It's crazy what our customers are doing and how much engaged they are and how vibrant the community is. And then on July 13th, we launched the DeepRacer Evo sensor kit, which now allows you to take those models that you trained in the virtual environment and actually get to see them in the real car. And we previewed this at reInvent this past year in 2019, but now it's time for the developers to go on and show us what they can do by training these models and deploying them down to the car.
So I live in New York. I've been a lifelong New Yorker, but when I lived in the Bay Area a little while ago, I saw a lot of these cars that would drive around in the streets. And when you mentioned these spinning LiDAR sensors, I feel like I saw a lot of those around. Are we talking the same type of technology here?
It's similar. Most self-automated driving cars actually are based on perception models, not reinforcement learning, but they do have a bunch of LiDAR sensors depending on the company and how they've implemented the self-driving car. I think it'd be pretty hard to implement the self-driving car without LiDARs, but not my area of expertise. So.
Great. Well, one of the things as someone who's followed along with the DeepRacer League over the past year is the concept of AWS subject matter experts who help service at the events and work on some of these cars and help folks load their models on, much like in F1 or traditional racing, we call that the pit crew. And so part of being in the pit crew is the ability to work and manipulate this physical device, the DeepRacer, that has a lot of traditional parts to a regular traditional car, but with some extra bells and whistles to handle the machine learning model and performing that inference on the fly. I was wondering, is there any chance we would actually be able to get a look at some of this hardware for the DeepRacer Evo?
I want to see it. I think that'd be cool.
But Chad, you want to see this real car?
Yeah.
Well, just happen to have one right here.
Oh, wonderful.
This is DeepRacer Evo, and you can see the LiDAR spinning up here. Hopefully you guys can tell that's spinning. And now the car really has two batteries. There's two parts to it. So right up here, maybe we start with regular DeepRacer, and you can kind of take a peek. This is sort of the brain of the device that's housed in this case. This is where we have an Intel Atom processor, which is what makes all the decisions. It's the CPU and GPU that manages everything that goes on, all the software systems on the device. And so that's powered by this fellow right here, which is the compute battery, which conveniently slides underneath the case over here. And then down here, and I don't know if you guys will be able to see it, but it's the servo. So these are sort of the DeepRacer's legs. And this is the little motor that makes this essentially an RC car and makes it go. So now let's talk about, and then there's one more feature, which is this back LED that we added for customization. So, you can customize your DeepRacer whatever color you want. I think we offered about 8 colors. And so now with the Evo, so that's kind of DeepRacer V1. And then with the Evo, what we did is we added, you see now there's 2 cameras. So originally for the DeepRacer, there would just be 1. So these are they kind of look like eyes, and that's because they're doing depth sensing. So this is how we do it. And you could take these things off. Let me not try in the sense that I may actually put this whole thing down here since it's a demo. But you can take these off and go back to the regular DeepRacer, the non-Evo version. And likewise, you could take off the LiDAR. And so the LiDAR mounts up here. It has a nice mounting plate. And then that's pretty much the gist of it. So once you get this guy, and you can just add in the 2 sensors and get our latest software, and you can convert your car into an Evo.
Eddie, where's the nitro booster?
Well, we're still working on that one.
Of course.
We'll take this back to the product team and see how they feel.
I'm still waiting for us to have a like an open circuit competition where people can mod their DeepRacers and just show up with any ridiculous sort of contraption that they've modified, like supercharged batteries or supercharged processors, like almost the crazy CPU benchmarks, but for your own DeepRacer.
And Nathan's comment about how when is it going to fly? Hover DeepRacer, please. I feel like we're slowly going to edge our way toward like an AWS BattleBots league instead of a DeepRacer league at some point.
Well, I don't know. I mean, the future is definitely, we're always looking for new and creative ways to teach people about great technology that is machine learning. But interestingly enough, at reInvent, if you made your way down to the pits in 2018, and I believe also in 2019, you could actually customize your DeepRacer shell, and people came up with all sorts of interesting customizations that made them look really, really, really cool. And we had a contest on that as well, as to who had the best customization, putting stickers on it. So not quite as exciting yet as bringing your own CPU and doing all these interesting things to make the DeepRacer just zoom its way through. But we do allow some customization.
Well, Eddie, everyone knows that putting flame decals on the side of your DeepRacer shaves at least 3.5 seconds off your lap time. So that's, of course, what I did to my shell. But we actually had a question in chat around sort of the basics of how this works, because, hey, we're AWS, we handle cloud computing. They're wondering, is the DeepRacer sending the real-time input up to the cloud to be processed to make decisions, or where is that actual decision making happening?
That's actually an excellent question. So remember from earlier in the talk, we have two things. We have the virtual environment, and we can talk a little bit about how that's architected. But as you guys have mentioned before, that runs on RoboMaker and SageMaker, and we have those two. So we basically orchestrate a communication between those two services, where we collect data on RoboMaker, and this is on the virtual environment, and then we send that data over to SageMaker. Now, once you've trained a model, and this is what's cool, the service will actually give you what's called a frozen model, and it doesn't mean we put it on ice or anything, but it basically means that it's ready to deploy onto the device. Now, once it goes onto the device, we run on the DeepRacer software stack on the device uses an inference engine called Intel OpenVINO. And Intel OpenVINO optimizes the model so that it can run as fast as possible. And then it actually runs on the CPU on the device. And then what happens is like, from the Evo, you get data from the two cameras and you get data from the LiDAR. That LiDAR goes to the model, and then the model, the machine learning model here, makes a decision as to what action you should take. So should you go left? Should you speed up? How do we navigate this track? And that happens at around 15 FPS. So every 66 milliseconds, we're making a decision as to which way we can drive and how fast we should be going. And that's the behavior that you guys incentivized up on the cloud in the actual service.
Awesome. And that makes a lot of sense, right? If you're accepting real-time inputs as you have a moving vehicle, you would want the time for making those decisions to be as low as possible. So moving that model off of the cloud and onto the actual device, while challenging from a compute and a powering perspective, is really the only way to have something like this that's truly responsive in real time, right?
That's absolutely right, Nick. If we tried to hit the server, just the simple latency would just kill us. If you think like good latency at like 100 milliseconds, for example, is too much. I mean, you're going too fast. Your car is going to go off the track, and you're going to end up against the wall.
Maybe someday we can deploy an outpost to run a local server and run a compute on the outpost just 10 feet away.
You could do that. Not impossible. You could totally do that, but you find you get a really good performance by running it on the edge, which is what it's doing. And it's probably a lot cheaper than running a local outpost and easier to set up.
Yeah, it might be a little bit cheaper. I think that's the understatement of the century there. Now, Eddie, one thing I feel like we need to remind the chat on a regular basis here is that what you've described there is the end-to-end flow of what it's like to actually take your model and run the car on the track. But in fact, to improve this iteratively, you don't need the physical vehicle, right? You can do this in a simulator. And that means that you don't need to buy one of these things in order to start, refining your model, getting ready to compete in the league. And I want to just make sure that message gets out.
That's absolutely true, Robert. You don't need a AWS DeepRacer device to get your hands, to basically start learning about reinforcement learning. You could go to the AWS DeepRacer console, and you could get going right there. You can iterate there, and in fact, you're absolutely correct. You improve your models on the AWS DeepRacer console before you deploy them down to the device. You can race in our virtual league, and you can basically just get all those learnings on there. But there's something really cool about like seeing something in a simulated virtual environment and then taking that and deploying it down to the device and actually seeing it do it in real life. Because, you know, in a lot of machine learning applications, you don't really get that sense of gratification. Most of the time, you know, as data scientists, you are looking at metrics to determine, and all that stuff's really important. But there's just something that makes me smile every time I go down to the pits and see people racing it and seeing it for the first time. That experience, I think, you can only really get with the device.
Yeah, the excitement is really palpable. You know, if you're ever, there's lots of actual footage from DeepRacer League and as well as the events in person and the online variant as well. You can check that out on YouTube if you want to get a flavor for what that looks like. But I'm going to point us to the new challenges within DeepRacer Evo that it can help us, new competitions that it spurs that I will say will will make the excitement for these races even more exciting. So again, the previous goal was to make it around the track as quickly as possible, and this may still hold true. But with these new sensors, you mentioned we can detect some new parts of our environment. What are the new challenges that we enable in DeepRacer League or with DeepRacer Evo now?
Yeah, so we actually introduced 2 new racing formats. We have object avoidance, where we put some boxes down on the track, and your task is still going to be to get around as quickly as possible, but now you have to teach your model to dodge these boxes. Because if you crash into them, well, you get a penalty. It's not good. And then we also enabled head-to-head racing. And the way we train this into what we call bot cars, which are sort of cars that are on prescribed paths around the track. And then you have to be able to avoid those cars and deal with lane changing and things of that nature. Now here it's a little bit different. We run, we have a qualifier at the end of the month and then we race the top 32 racers against each other in a tournament head to head. So in a way, you still want to go faster, but you want to go faster. You want to be able to beat your opponent, and you want to be able to not crash into him or her, because otherwise, you get a penalty and you're not doing well. So this is really the new racing format that the DeepRacer Evo allows us to do. And so these have just been super cool. And we've seen a lot of just people enthusiastic going at it and, going at it on the leaderboard. And then, again, just to bring back the F1 event where we actually held a 12-car Grand Prix where you got to race against, if you qualified for the Grand Prix, you got to race against Daniel Ricciardo and Tatiana Calderon, which are both F1 drivers. So all this super cool stuff is really enabled by having those extra sensors out there.
Awesome. And you may have mentioned this before, given sort of the relationship between the sensors and the base DeepRacer vehicle. But just so that it's very clear, the release of DeepRacer Evo hardware, you can either buy both of them as a bundle, or you can buy the new sensor kit and apply that to your existing DeepRacer vehicle. So if you've already purchased one, you can simply apply the new kit to it, right?
That's absolutely correct. And in fact, if you got a DeepRacer as early as reInvent 2018, you can go on Amazon.com, purchase a DeepRacer Evo kit, which is available at a limited price, a limited offer of $149 today. And you can take your car and then turn it from a DeepRacer to a DeepRacer Evo. Or you can purchase a DeepRacer car with the Evo sensor kit together, have it shipped to your home, and get started with DeepRacer Evo right away.
Wonderful. We mentioned before the experience of, you simulate in the console and you load that model onto the vehicle. When I put on my engineering hat, I think like, loading a model somewhere, maybe I'm not proficient in machine learning. That sounds like it could be daunting. Maybe you could walk us through just like the steps, either verbally and console, whatever you think would be easiest for basically just like loading a model onto the DeepRacer. Because I think this distinction of like, going from the cloud to the physical device, they're quite literally separated physically. How easy is that experience with DeepRacer?
It's extremely easy. All you have to do to load a model onto the device is you download a model from the AWS DeepRacer console. Once it's ready, there'll be a button that says download model for deploying it on the car. and that's going to download essentially a tarball. And then all you have to do is basically go to the AWS DeepRacer console, which you can access on your browser. And now I think one thing that to mention here is that the device console runs locally over your router. So you get the IP out, and you do that when you register, when you provision the device. So you hit the DeepRacer device console, and then there's literally a button that says load model, and then you just load the model, and that's it.
Awesome. Very exciting stuff.
Yeah. Sounds very intuitive. I wonder if we could see a demo of it.
We can actually, if you guys want me to share my screen.
Yeah, go right ahead. I know the fans in chat are chomping at the bit to see it. So.
Cool. Give me just 1 second here to make sure that this is up, and then I will share my screen and show you guys basically what the Evo looks like and where you can just load a model.
Awesome.
And it'll be relatively straightforward, as you'll see. And again, that's all you really have to do. And let's see if it'll come up here for me in a second. This is live TV. I just had it up.
Yeah, while you're sharing that screen, I guess I'll give a recap for folks that may have just tuned in. This is the AWS What's Next show. Lots of recap, AWS being Amazon Web Services, the technology arm of Amazon, create lots of services for developers to power the technology, webs, apps, experiences you see on the internet today. We spoke a little bit earlier with IVS, the interactive video service, the tech that powers Twitch, recently released as a service from AWS. So very exciting there. And right now we're joined by Eddie Calleja talking to us about the AWS DeepRacer, a fully autonomous vehicle, a miniature vehicle that you can train your own models for using machine learning reinforcement learning to be more specific, and then see both through the simulator or in person how your vehicle will react and travel around a racetrack. Eddie showed us some of the bits and pieces and the new features with DeepRacer Evo, the LiDAR sensor, the ability to do depth sensing, and we're just about to see a demo of actually using the console to be able to experience this.
Yep. So I'll go ahead and share my screen.
Yeah.
And 1 second here. Live TV Zoom is.
Yeah, no worries. If there's any errors, just let me know. It might be something on my end.
It's just.
Yeah.
Okay, there we go. Okay, cool. All right, can you guys see that?
Yeah.
So this is the AWS DeepRacer device console, and I've actually put us where you would go to load a model. So you see the model, the selection here of what we have, and we'll go back to control vehicle in just a second. So I've already loaded a couple of models on here, and these are sample models which ship with the software. So these are models to sort of get you going if you don't want to train a model and you just want to see the car do some avoidance or use some of the sensors. We provide these for you. They tell you what the sensor configuration is. So for example, this one is just stereo camera without the LiDAR, so it doesn't have the LiDAR signal. This was essentially an old, I don't know, you may want to call it an older DeepRacer model where it just has the one camera. And then this is one that leverages LiDAR and the sensor camera. So when you come from the AWS console and you download your model into your computer, you could just hit upload model. This is going to pull up, just as you would imagine, a file selector, and then you just click on your model and it loads it here. And that's it. That's the whole model uploading procedure. Now, once you've uploaded your model, and you guys are seeing sort of my living room here, this is actually the landing page for the AWS DeepRacer Evo. And we've added some new visualizations such as LiDAR, and you can see the LiDAR right now is moving around, and the reason for that is because I'm putting my hand actually next to it, so you can see it actually physically detect things close to the device. And if we wanted to load a model, all we'd have to do is go here from our model selection list, and this is only going to allow you to load models that the model was trained with a particular sensor configuration. The model doesn't work if, let's say I train something with stereo and LiDAR and I don't have LiDAR plugged in, then it's not going to work, which is why we have here a display showing you what sensors you currently have connected. And so, if we just click on this, it'll ask you, hey, do you want to load this model? And you say yes. And it takes about 10 or 12 seconds. And this is because just sort of like loading a model requires us to load all the weights and all the math sort of speed into the GPU. And this takes a little bit of time. But once it's all set and ready to go, this will turn green, and then that's it. Then we would hit start, which I'm not going to do because the DeepRacer is going to fly off my
It's going to avoid the chair and fly right out through your window.
It's quite possible it may do that.
We'll keep one hand on it so that it doesn't do that. But I was just going to point something out. So if you look up there in the address bar there for the URL, you'll notice that's not a publicly available website. That is an IP address locally for the actual DeepRacer. So what you're looking at here is, and correct me if I'm completely off base or have saying anything wrong, but this is not the console where you sign into the AWS Amazon console. This is you connecting through your browser on your local network directly to your device, and you're interacting directly with it through this GUI.
That's absolutely correct. So basically, if this runs on your router, this is how you connect to the device. And most of the time we won't connect to the device the way that I'm doing here, which is from my computer. Most people connect via a tablet or a cell phone because you want to drive it around. So one of the things you could do is you could put it in manual mode, and you get a little joystick, and this thing right here will allow you to drive the car just like a regular RC car. If you want to have some fun, or if you wanted to go chase somebody around, you could do that with this, as long as you're on the network. But that's absolutely correct. This is not from the console where you train stuff. So we have two modes: autonomous mode and manual mode. And in manual mode, you're actually physically driving the car. It's not the reinforcement learning model that drives the car.
Well, I think that also answers one of the questions we had in Twitch chat about whether you can manually control one of these things. And the answer is yes. It appears as a device on your network with its own IP address. Eddie, just wanted to forward another question to you. And I think this one we're going to see throughout the rest of the demo, but here it is. How much freedom do we get from defining our own functions in the standard RL formulation? For example, can we define arbitrary policy, value, and reward functions?
Well, you can define arbitrary reward functions up on the AWS console. In fact, one of the cool things that, how we wanted to onboard people with reinforcement learning is like, well, the reinforcement learning, like you mentioned, I think Nick, you mentioned that it seems really scary. So what we did is, hey, let us take care of some of the reinforcement learning algorithm, and let's ease you into this. And the way we're going to ease you into this is by focusing on the reward function. And so you can go on the AWS console and you can basically craft your own reward function. You can craft as many of them as you want. In terms of value functions, we currently only offered an algorithm called PPO, which stands for Proximal Policy Optimization. And we use that within an algorithm called actor critic. And this is all within a paradigm called the function approximation. And that's pretty much all just jargon out there. But it basically means that you don't define the value function, because the value function is in fact a neural network that you learn, which is what the actor critic algorithm does. It's basically you're simultaneously learning a neural network for the policy and a neural network for the value function. So that was a very, very poignant question. That's a fantastic question. So you don't get to tweak the value function, but you do get to tweak the reward function all you want.
Eddie, that was a wonderful answer, and I think it sort of speaks to the depth you can take DeepRacer, right? You can use it at this very high level and get onboarded in an easy to digest manner. But if you want to really explore the underlying components of how the reinforcement learning works, that's possible here. And many of the folks like yourself that are probably out helping as members of the DeepRacer pit crew are the ones you can ask those questions to. So that's super awesome. I have a similar question that is equally as pointed, but much easier to answer, I think. Are you ready?
I'm ready.
All right. So you showed me that dashboard. I can hit plus and minus on speed, right?
Yep.
when am I able to take a piano pedal and use that as an IoT gas pedal for my DeepRacer device? Because that's what I'm waiting for.
Not quite yet. Yeah, you're absolutely right. We actually, with the DeepRacer Evo, we increased the size of that because we found that a lot of our customers were using it, again, in the tablet or cell phone settings. So we made it bigger so it's easier for you to increase the speed. Yeah, we're not quite there yet on the gas pedal.
Yeah.
I love that idea. I hope the product team's watching. They're getting a lot of good ideas here from this chat.
Yeah. How about streaming the stereo cameras to an Oculus Rift or something, and then combining that with the gas pedals and having the out-of-body experience of you driving the race car around?
The out-of-body experience of running a race car around. That's definitely a much more complex project. We're not quite there yet.
I like the even-handed handling of these crazy ideas.
Yeah, this is where I feel like, honestly, if I were in some of the early meetings listening to, we're going to make a reinforcement learning powered car and build it for developers, like that would probably at the time sound just as, off the wall, but here we are, right? So these ideas and features come from conversations just like this. And I will bring an amazing one up from chat. Janiscu, one of the returning viewers to this show, is requesting an IoT integration for the Power Glove. So that you can probably steer or control throttle.
Well, I would say we're always looking for new and creative ways to improve the product. So we'll definitely take those suggestions.
Diplomatically said.
That's amazing. Oh, man. Awesome. So this is DeepRacer Evo. And so, for folks that have worked with DeepRacer before, this in-console experience, a lot of this hasn't changed, but some of the new stuff, again, the toggles up for LiDAR, the ability to share both your LiDAR powered models or your traditional models without the LiDAR sensors, all still in line. So for returning folks to DeepRacer, experience looks very familiar, but now with some augmented superpowers, I guess you could say.
That's absolutely correct. And I'll log us back in here. All right, that should come back up here. Hopefully I didn't forget the password. That's absolutely correct. So we've added support for these new sensors and visualizations to help you kind of see what the sensors are doing and what inputs you're actually sending to your reinforcement learning model. So it's kind of has a feel of, you're familiar with DeepRacer, you're still gonna see some of the same stuff. It's still gonna feel familiar to you, but we've added some new things to really help you get rolling with reinforcement learning.
See what you did there. Get rolling, DeepRacer. Now you're thinking of portals. We've got some more.
We've had so many puns around this product. It's kind of you kind of come to realize how many driving puns you can make in natural conversation every day. Because every time when you're talking DeepRacer, you say, "Well, I'm gonna drive this idea home," and it's it immediately everybody's like, "You're making a pun about the DeepRacer." So it's been super cool on that front too.
Chat is going wild. I know you're probably not able to see it, so I'll just pass it along. People are waiting for the the DeepRacer brains to be able to apply to a go-kart. People are wondering when there's going to be the Roomba versus DeepRacer object avoidance competition or the head-to-head comparison. They're just, man, this is great. I love this.
Yeah, and it's fantastic. And I would say this year we increased to 3 formats, and like I said, we're constantly looking for ways to engage the community in a fun fashion. So I would just urge everybody to stay tuned and see what we can come up with here in the future.
Awesome. Yeah, so after you some issues with password, the hardest part about technology is still humans, as we can see. But the for next steps, the only thing we haven't shown today is quite literally hitting go on that model after it's been loaded. So you showed before loading and selecting the model. Let's say we've trained one up in the simulator, we've now loaded it onto the vehicle. Now all there is to put it down on the track and to let it go and to record the track time, right?
That's pretty much correct. I mean, we could try to. I don't know what will happen if I turn it on. Guess if everybody wants to see it, we could try it here.
We'll give it the good old college try here.
Give it the good old college try if I able to get the. There is. There it is. Well, I may not have the battery charged actually.
Oh yeah, we're getting a vehicle battery not connected error there in the.
Yeah, so unfortunately we can't get rolling because we don't have a servo battery to get this to go. But you're absolutely correct. All we would have to do is hit the go switch, and that would be it. And the car would just take off, so to speak.
All right.
And then, well, there's actually one more step. So one thing about this is that we're training, and one thing about reinforcement learning and where it is today, just as a science, is that we're training for a track. So if we just hit go, yeah, it may avoid the chair and fall down, but it hasn't really been trained on this environment, which is my living room. So it's not going to know what to do. So if we just hit go right now, it's just going to take a bunch of random actions. So we actually need to lay down a track so that it can pick up on the visual cues that it learned while training, and then it would actually follow the path on that track. And there's some great instructions, and I hope some folks can put it down in the chat and links to how to build your own tracks and how you can do that so you can actually have the device, you can actually see that behavior transfer from the virtual environment down to the real environment.
Wonderful. Yeah, we're gonna make sure to get all those resources in chat. But I guess in recap here, all of the resources for folks who are excited by this and want to get started. We have the launch blog post for DeepRacer Evo to sort of walk users through what it looks like to get started with these new data inputs, or the new sensors for LiDAR and depth perception. There is you will go into your AWS console. You can start training your own model in the simulator there. Out of curiosity, I'm actually not familiar. Is there a free tier for DeepRacer at all?
I believe there is a free tier for DeepRacer.
Okay.
Let's double check that on the chat. But I believe we do have a free tier.
Yeah. So, okay, awesome. Because where that leads us is that, even short of buying any of your own hardware, if you sign up for AWS, you go into the console with whatever the free tier for train. I'd imagine it's some amount of hours for training in the simulator. You can go through the Hello World tutorial for training your first DeepRacer model, and actually, I'm pretty sure you can follow along sort of that like eagle eye view or that like POV view of your car going around the track in the simulator. So for the lump sum of free 99, you can get your hands wet with some of this exciting reinforcement learning simulation.
Yeah, absolutely. So we have a sort of an initial, if you're just new to the AWS console, we have sort of an initial primer that walks you through the steps and some of the concepts of reinforcement learning, and then once you go through that, you're pretty much ready to go and ready to train your model. So it's the fastest way to train a reinforcement learning model on the AWS DeepRacer is.
That's awesome. Thank you so much, Eddie. I couldn't think of a better guest to take us through all of the new features that we're launching with this.
Well, thank you guys. This has been awesome.
Yeah. So again, Eddie Calleja from the senior software engineer over on Amazon AI has been with the team back since the inception of DeepRacer and is here today. Told us a lot about Evo, showed us it in the console, gave us the walk around. Eddie, one-stop shop for everything DeepRacer. I can't thank you enough.
Well, thank you guys. This has been awesome, and thanks everybody for listening to me here for the last little bit.
Awesome. Well, I know chat very much enjoyed it. They really enjoyed getting to see us go hands-on with it. But the show must go on. Here at AWS What's Next, we are wrapping up our second session here, but we do have a new format for our third session. Quite familiar, but with some different faces. You're probably used to Rob and I leading each session, but we've got something a little bit different here lined up for the third one. We are going to be going hands-on with AWS CoPilot, and when we were thinking about people that would be the most effective hosts for this, we had to look no further than our own developer advocate team that lives on the containers team with Nathan Peck. Nathan will join in just a moment after we come back from our commercial break. But, we saw his name at the top of the blog post for announcing AWS CoPilot, and I figured inviting him out would probably be the most effective way to tell the story of AWS CoPilot for developers that are used to using ECS and containers. Gene is teasing me in chat for my hair. I know, I live across the street from a hair salon, and it is still closed here in New York. But something that is not closed is Twitch. I know that was a terrible transition and segue, but to bring it all together with AWS CoPilot, Nathan will be introducing himself and our esteemed guest to talk a little bit about CoPilot right after the break. So stick around. We'll be back with session 3 of the day. Thanks, folks. Be right back.
Welcome back to AWS What's Next. I'm Nathan Peck. I'll be your host for this next segment. And today I'm joined by F.A. Caracas from the ECS Developer Experience team. So
hello, everyone.
Today we're going to be talking about a recent launch called AWS CoPilot. And if I understand correctly, this is an open source project which was released on GitHub a few weeks ago. And it's already accumulated over 760 stars. So what exactly is this that folks are so excited about?
Sure, yeah. So AWS CoPilot is a new command line tool to help customers build, release, and operate containerized applications on AWS. We launched it on July 9th at the AWS Cloud Container Conference. It's, like you said, it's developed by the Amazon ECS Developer Experience team. It's completely open source. You can find it on GitHub at github.com/AWS/copilot-CLI. Please give us any feedback, feature requests, any issues that you might come across. We'd love to hear from you.
Awesome. So first of all, congrats on the launch. Now let's go through a few terms. You mentioned a few things. I want to make sure everybody in Twitch chat and listening in, maybe on LinkedIn or wherever else we're streaming, understands the terminology we're talking about. So you talked about command line app. Obviously, there's different types of applications that you might run. What exactly is command line in this case?
So by command line, we mean this just like a tool. If you're familiar with the AWS CLI, for example, it's just like the AWS CLI. You would use Copilot on your terminal.
Okay, so I'm not going to be using this on the web console. I'm going to go to my terminal. And then you mentioned containerized application. What is this container we're talking about? We're not talking about a box here. What is the container?
Sure, yeah. So like you said, the containerized application, it really has two terms, right? Container and application. And by container, what we mean is a technology that allows developers to take their code, their runtime engine, for example, Node.js, any dependencies that they might have, and package them up into a container image. Then this container image can be run on any machine that's running Docker. So it's a super easy way of making sure that your software can run really on any machine.
That's awesome. Yeah, I know in the past working at various startups and writing code, I often ran into issues where, I wrote some code on my development laptop and then I handed it off to another developer and the code didn't run right, or we tried to deploy it to a server in the cloud and it didn't run. And so we had to figure out, okay, well, how are we going to get our code to run reliably in every location that we want to run it? And containers was a solution that we came upon specifically because of what you said, which is that it allows you to package up all those applications of the code I'm writing, the program I'm using, the runtime to actually execute my code, and any other libraries I need. So that's huge. So with CoPilot, so we know what the containerized application is. What's the problem that CoPilot is solving when it comes to actually deploying this containerized application in the cloud?
Sure. So first of all, CoPilot provides an end-to-end experience for developers to both build as well as releasing as well as operating your containerized applications on AWS. So when you think about the AWS landscape now, we have lots of great building blocks, right? We have the Amazon Elastic Container Registry to manage your container images. We have Amazon ECS, the Elastic Container Service for container orchestration to make sure that your containers are always up and running. You can do auto-scaling, lots of management stuff for your containers. And we have many options for databases, right? For example, Amazon DynamoDB. And developers right now, they have to do a lot of glue work, right? You need to figure out, how do I connect an ECR repository with my ECS service? How do I connect my ECS service with my database? It's not about just doing this like glue work. You want to do that with best practices in mind, right? You want to make sure it's like cost effective, it's reliable, it's secure. And CoPilot takes that burden away from you. What we do is that we take as input a Docker file, and then you tell us what kind of architecture you want. For example, I want a load balance web service. I want to take this Docker file and just run it on AWS behind the load balancer. And CoPilot will figure out all this glue work for you. It will provision the infrastructure with best practices in mind.
But that sounds amazing. I know every time I start a new application and I'm thinking about what architecture I want to deploy, I'm always worried about, did I accidentally leave a port open and like some hacker is going to get into my database? Did I accidentally get my permissions model right? And maybe somebody's going to be able to get into my S3 bucket. So having something there like CoPilot to help me design things properly and make sure I have my settings correct, that sounds amazing.
Mm-hmm.
Yeah. So tell me a little bit about what happens next. So I use CoPilot to deploy the application. Once it's deployed, what else can CoPilot do for me?
Yeah, so by providing an end-to-end experience would mean exactly like you said. Your application, as an application developer, you don't stop at just like building and modeling your infrastructure.
Mm-hmm.
And afterwards, the service is up and running, and you need to troubleshoot if a problem occurs, right? So CoPilot is also there for your operational commands. So you don't have to context switch to a different tool. You can do both your infrastructure provisioning as well as operating your service through the same CLI, through the same tool. So you would do, for example, like CoPilot service status or CoPilot service logs to be able to view the health of your service or to be able to view the logs for your service.
So what does CoPilot do that's different from other infrastructure provisioning tools? Because I've used different tools to deploy. Sometimes I go into the AWS console directly to build out my application. I've used like Terraform, CloudFormation directly. How does CoPilot compare to those experiences?
Yeah, great question. I mean, like you said, we have so many tools out there, right, to be able to do infrastructure provisioning. But CoPilot is not just an infrastructure provisioning tool, like we were saying earlier. It also allows you to operate your service. So you could do like service status, service logs. Mm-hmm. But in terms of just infrastructure provisioning, CoPilot under the hood uses CloudFormation. But if you were to use AWS CloudFormation directly, you will be starting at a blank template. So you would have to define every single infrastructure resource yourself. Instead, with CoPilot, you just get these pre-populated templates, right? Because as an input, you tell us, hey, I just want something behind a load balancer, or I want a service that's private that only other services in my application might want to access. And then we'll like populate the template with best practices in mind. When we compare it against the AWS Cloud Development Kit, the CDK, CDK is also an abstraction on top of CloudFormation. But instead of defining your infrastructure resources in YAML, you would write in your preferred programming language, such as Python or TypeScript. But with Copilot, one of our differences is that we can provide deep integrations between your ECS services. For example, if I want to add multiple services that are behind the load balancer, I can, with Copilot, that will automatically get added under the same load balancer. But if you were using CloudFormation or the CDK, you will need to think a little bit deeply about, I need to take this load balancer, place it in a separate CloudFormation stack, then take my services and place it under a different CloudFormation stack, make sure that they are wired up together sensibly. Copilot abstracts that away from you. We also recently announced an integration between Docker and ECS. And that's a great starting point if you're using Docker Compose. If you're really well familiar with Docker Compose, it really eases your life with getting started with ECS. But with Copilot, we provide some deep integrations between other AWS services. For example, we provide nice way of integrating with DynamoDB or an S3 bucket. We can also set up an AWS code pipeline for you.
Wow. So for those who may be familiar with how we build services and offer new features at AWS, one of the things that we do before we actually define anything, before we start writing any code at all, is we like to create a set of tenets. So I want to ask, with Copilot, what are these tenets or principles that are guiding how Copilot was built and how the experience was designed for these end users of Copilot?
Yeah, so as we said earlier, Copilot is open source. You can find it on GitHub. And in the repository, we have a file there named Charter. That's where you can view our design tenets if you're curious. The first design tenet that we have for the CLI is that users think in terms of architecture and not of infrastructure. For example, developers that want to create a new microservice, they shouldn't really have to think about all the networking configuration. You might not even know what's a VPC, subnet security groups, load balancer settings, or complex pipeline configurations. Instead, as developers, when we're building a new application, we really like to think in terms of black boxes, right? Like we'll say, okay, I want a microservice that's fronted by a load balancer, and that will connect to a database, right?
Yeah,
and that's
when I'm designing a new application, the first thing I do is I go on that whiteboard and I put a little box, and I put an arrow over to another box. I'm not actually thinking about the rules and lower line configuration. I just think about this box connects to that box connects to that.
Yeah, you don't think about the target group of how I'm going to configure that, right? So that's exactly the type of input that we want to take with the CLI. With Copilot, you provide your Docker file so that we can create a container image from it. And then the second input that you provide us is what kind of service you want in your application. So if it's a load balance web service, we'll put that behind the load balancer. Or if it's a backend service, then it's going to be not public, so nobody from the internet will be able to access it, but your other services will be able to access it. The second design tenet that we have with the CLI is creating modern applications by default. And by modern applications, what we mean is really, just like what you described earlier with the microservices and black boxes, is that you typically tend to have more than one microservice in your application. So you'll have multiple microservices. You might have some jobs. You might have some supporting resources like databases. And with the CLI, we ensure that all parts of your application are wired together securely and sensibly. So this is my favorite tenet of the CLI, because what you were saying earlier is that I don't want to have to think about how to create the roles to be able to really access this database, right? So for example, when you run Copilot storage in it, we'll create either a DynamoDB table or an S3 bucket, and we'll automatically add permission for your ECS service to be able to read and write from that database, as well as inject any environment variables that are needed for you to be able, from your source code itself, to be able to access the database, right? So we can provide this sort of deep integration between other AWS services with your containerized service. Our third tenet is delivering applications continuously. So while the AWS Copilot CLI can be used to manually deploy changes, so I can type Copilot deploy and it will just deploy to the environment, we always help customers to move to a continuous integration and continuous delivery pipeline by managing, and setting up pipelines. So we all know as developers how important it is to set up continuous delivery pipelines. It results in increase of software throughput, better software quality, as well as like happier devs on your teams, right? You don't have to create approvals and like make sure you chase someone else, a manager, to get an approval for a deployment.
Yeah, I remember some of the startups I worked at in the past. There was only one person who could do the deployment. Sometimes that was me. Sometimes it was someone else, and then they would go off on vacation for the week, and I'd be like, "What? We can't actually get any of our code onto servers right now because this person was the only one who had access to actually take the application that we had built and deploy it to the server." So that meant maybe there was a bug that would be impacting customers for a couple of days. And that's
exactly. Yeah, we want to avoid that. We definitely don't want to be in that situation. So with Copilot, what you can do is that you can create multiple deployment environments very easily. You type Copilot nvinit, and you can say, hey, I want to create a test environment or a deployment environment. And each one of these environments can be in different AWS accounts or different regions. And then you type Copilot pipeline in it, saying that, hey, I want to wire now, my first stage in my deployment will be the test environment, then a production environment, and we'll release all your services automatically. So that will create an AWS CoPipeline pipeline for you. And you don't have to go and hack, any release scripts yourself or wait for someone else, to go and deploy your changes for you. And the last tenet that we have with the CLI is that operations is part of the workflow. So this is what we were trying to say earlier with the definition of what AWS CoPilot does by providing an end-to-end experience. Provisioning, so far we've been talking about provisioning, modeling, resources, infrastructure resources, but that's not the end of the story. We want to be able to help you troubleshoot and debug when things go wrong. Right? So we provide commands to help monitor the health of your service as well as visualize the logs. I'm super curious what we can do there, right? Like if you have any ideas on how we could set up traces for you, maybe automatic metrics and alarms and dashboards, would love to hear from you. Just create an issue on GitHub for us, and we'd love to hear back.
That's awesome. I see a few questions in the chat I wanted to highlight. One question is there any way to import Docker Compose file? If somebody's already been using Docker Compose, what's their path from Docker Compose into AWS CoPilot?
So right now, there is no way for you to be able to import a Docker Compose file, but instead, in Docker Compose, you define individual services. You can still do that with Copilot. You would be running one by one for each one of the services that are available. If you're curious, you can alternatively check out the Docker ECS integration that was recently announced. Those will be the two paths that you could use with going from Docker Compose to ECS.
Yeah, that makes sense. So we've been talking about Copilot a lot. I understand you have a demo you'd like to show us. I always like to get hands-on and actually see this code running, see some video of the terminal going. And let's do it. Let's see what Copilot looks like.
Yeah, let's do it. Okay. So I think I should need to share my screen. Hello, can you hear me?
Yeah, you should be able to share your screen.
Okay. Somehow my screen froze, but.
Uh-oh.
Okay.
All right, so, there we go.
Okay, am I good? Can everyone see me? See the terminal and everything? Okay, perfect. Okay.
We can all see the terminal now.
Okay, perfect. So I'll be giving an overview of how you would go by, using Copilot to deploy and manage a containerized application on Amazon ECS and AWS Fargate. Over here, I have a sample Git repository named Vote app. I ran 3, so we can see all the files that's in my repo. Just for this demo, I have a very simple application with 3 microservices. Right? I have an admin microservice. You can see from the Docker file. It just renders an HTML page. I have an API microservice as well as site microservice. I've already run Copilot init for each one of those, so I've deployed these services already with Copilot. And once you deploy everything, at the end, you'll see this Copilot directory. Don't worry, we're going to take every single step that I've done for this again. I'm just showing you the end result right now. So with, for example, under Copilot, you'll see 3 different directories for each one of your services with a manifest file under them. And I'll give an explanation of what that is. And I've already set up continuous delivery pipeline for my application. And you can tell that by the pipeline.yaml file that's in here. Now, from the root of my repo, I'm going to type Copilot to see the help menu for the CLI. And you can tell that it's telling me that it helps me launch and manage applications on Amazon ECS and AWS Fargate. That's exactly what I want. We have a bunch of commands in the CLI, which are under different categories. For example,
I love how well this is organized and documented. It's very clear to me right away. You know, I can see that I get started, I develop, I've released, and I just kind of go through the flow from the top down to get my application running.
Yeah, and I love the little emojis over here. That's my favorite piece. So right now, you know, like you were saying, we have a getting started category. That's if I'm brand new and I want to start an ECS application. The develop commands, you could use them to do both like evolving your application by adding additional microservices, or you can do some operational commands such as service log or service status here. Finally, we have 2 different options for releasing your services, right? I can set up a continuous delivery pipeline, or I can do a manual deployment. And I can associate my services with additional AWS infrastructure with the add-ons commands. So for example, I can add an Amazon DynamoDB table, or I can add an S3 bucket to my service. So what I'm going to do from here now is get started with Copilot. So I'm going to type Copilot in it. And the first thing that the CLI does, it welcomes me. It tells me that it's going to ask me a bunch of questions to help me started with an application on ECS. And then an application is just a collection of my containerized services that operate together. Since I already run Copilot before in this Git repository, it detected that I've created an application named VoteApp. The first question that it asked me is which type of service best represents your services architecture? And this is exactly what we're talking about earlier with Nathan about our first tenet being users think in terms of architecture and not of infrastructure. If I type question mark here, it tells me that a load balance web service is a public internet-facing HTTP server that's behind a load balancer. So this will be the architecture that I would use if I want a service that's accepting requests from the internet. Then I have a second option here that says a backend service is a private non-internet facing service. This will be the option that I would use if I want a database, a service that's talking to a database that no one else from the internet would be able to access. So I'm going to choose a load balance web service for demo. I'm going to name my service vote site. And then the next input is the Docker file, right? So in my repository earlier, I showed that we had 3 different Docker files, each one for our microservices. So the CLI recognized the location of the Docker file. And then it prompted us which one we want to use for this microservice. In this situation, I want to use site Docker file. And this will help us build the container image and then have that container up and running on Amazon ECS and Fargate. Looks like it created the infrastructure needed for the application. It says that it wrote something called the manifest file at this particular location. So we're going to take a look into that next. It created the ECR repositories. We're all good for local development. Next step is to deploy this. So we actually have our service up and running. So I'm going to say yes to this. And while the deployment is happening, I'm going to switch over to my next step so we can view what this manifest is all about. So let's take a look at what that looks like. I just opened up the file. So for each one of my microservices would get its own manifest file. And the manifest file is really our architecture as code, right? So this is our abstraction on top of CloudFormation that would provide you the most common knobs, the most common configuration that you might need for a load balance web service. For example, we have the location of the Docker file, we have which port is exposed, and Copilot will parse your Docker file to be able to detect if you have specific instructions, such as an expose instruction for your port, or if you have a health check instruction, and will automatically fill those values in the manifest for you.
Can I just interrupt for a second and say that this manifest is amazing. Like when I look at this, I've seen a lot of application configurations, you know, over the years, and a lot of them, they get really complicated. You have, you know, these JSON, these files that have all the semicolons, and quotes, and all that stuff. And what I'm seeing here is I'm seeing it has documented comments in there explaining what everything is. And just the settings themselves are very simple. I see like CPU, memory, count, stuff that I can kind of understand. And with the explanations there, like this looks like a way simpler way for me to configure my application without having to learn a lot of like basically magic keywords and magic settings that are in some really complex configuration format.
Yeah, exactly. We try to really like instill the essence of what a load balanced web service might look like. So you have your container settings with CPU and memory. You have your count, which is just the number of tasks that you might be running for your service. And here are like the configuration for your load balancer. This is the path that the load balancer should listen on and forward requests to your service, or you can set up a health check setting from the load balancer. We have some more advanced configuration at the bottom, so you can inject environment variables, or if you have any secret that is stored on AWS Systems Manager parameter store, you can inject them also as environment variables to your service. At the bottom, we have some environment overrides. So any of the values that you see over here, you can override them per environment. So you can imagine in this situation, we create everything with minimal settings, so it doesn't cost too much. But we can imagine that a production environment, you want your service to be reliable. So instead of a count of 1, you could set, hey, for prod, set a count of 3. So my service is reliable. Okay, so I'm gonna exit the manifest. That's what the manifest does. You can modify this and then do another deployment, or you could just commit this change and then do a git push if you have a pipeline set up, and that will trigger, you will automatically like increase the count of your of the task in your service to 3, for example. If I go back to the CLI, you can see that it says that, okay, environment test already exists in my application Vote app. That's because I've already run this command before, and it created all this networking infrastructure, like the VPC, the ECS cluster, the ECR repositories. So Copilot handles that for me. And then the next step that it started doing is that it built the container image from the location of my of the Docker file. And then it pushed that onto ECR. It says that it pushed it, and now it's deploying the service itself. So while the deployment is happening, I'm gonna put my operator hat on. I'm gonna switch from being like a builder, right? And I wanna see the status of my service. So I can type Copilot service, and underneath it, I can see that there is a show and status command. These seem relevant to me, so I'm gonna type Copilot service status. And the first thing that the CLI will prompt me is, okay, which service and environment combination do you want to show, right? So I've already deployed my 3 microservices to 2 different deployment environments, a test environment as well as a production environment. And I want to choose to visualize the service status for my both sites service in a test environment. So I'm going to choose this option, and boom, it tells me that, okay, looks like the deployment is over. Actually, I have 1 out of 1 task that's running. Everything is good to go. Last deployment was in a month ago. The status is running. And if you have any alarms set up already for the service, in this situation, I had set some alarms up. You can see the alarms and the status of your alarms through Copilot service status. So since the deployment is almost over, that means that the spinner should also go away pretty soon. But just to show that we really don't have any magic with the CLI, every single step that Copilot takes, every single infrastructure is provisioned through CloudFormation. So for example, this would be the stack for my Vote sites service that's in the Vote app application in the test environment. And you can see all the resources that we create for you that you don't have to worry about, such as service discovery for private communication, setting up all this networking configuration between the load balancer and your ECS service. We should see the log group, the ECS service itself, the task definition, as well as permissions with your task role, right? You don't have to worry about any of those. And I just saw earlier before switching to CloudFormation that the deployment is done, and even tells me at the end, okay, this is where you can access your service. It gives us the URL. So I'm gonna quickly copy this, go back to my browser, paste, boom. It says, hello from the Vote site service. The service is up and running.
So this is live, right? What happens if everybody in chat gets this URL?
Go for it. We have only one task running with minimal CPU and memory, so please be gentle.
But how would I go about scaling it up if I did want to handle, you know, all 2,000 plus people in chat accessing this website at once? I would do that through that manifest file, right?
Exactly. So let's do that. So just like to demo how that would look like, I would go to vote site, the manifest, and I would say, okay, in this situation, maybe I want, 1024, 1024, and I want to count to 3. And that should definitely be enough for everybody in chat to be able to like handle that. And I could do, let me type Copilot again to see the help menu. And for releasing, we had 2 different options. I could do Copilot deploy to do a manual deployment, for example, right? So let me type Copilot deploy. I'll take vote site again. I'll say, okay, now deploy with my new manifest to the test environment, and it will start the deployment. I'm just not going to do that for now, so we don't have to wait for another deployment to happen.
Yeah, that's fine.
But
that's fine.
I'll show like some other commands that are available. Yeah,
I can see how that's very easy though. If I was in a situation where I was running a website and I was getting more traffic than I expected, it's very easy for me to just change these settings and run Copilot deploy again. And I'm scaled up now. I can handle 1,000 people hitting my website if I needed to handle that.
Yeah, exactly. And if you forget any of the settings that like Copilot showed earlier, such as the URL of your service, right? I can type Copilot service show, and then I'll choose my service, and that will give me my configuration, right? So it will say, okay, right now you have, so the vote site service is a load balance web service. It's deployed in 2 different environments. Both have the exact same configuration here, minimal configurations. These are the routes that you can access the service, so the load balancer endpoints. And you can tell that we have 2 different load balancer, each one for a different environment. The test environment gets its own load balancer, and our production environment gets its own load balancer. We set up service discovery by default for you so that the service can be accessed privately through other services in your application. And we inject some of the environment variables that you might find useful, such as the DNS name for the load balancer, as well as the service discovery endpoint, so you can start leveraging this namespace from your application code. So what I'm going to do now is show some of the commands that's available to us to evolve our application, right? If I want to add a new service to Vote app, I can run, let me show Copilot service again. I can do Copilot service init. And in this situation, let's say I want to add an API that's communicating with a database. So I will choose a backend service. I'll name this Vote API and pick my Docker file again. Oops, I picked the wrong one. It's okay, it doesn't matter. So, and then it will create the necessary infrastructure here. So it will say that, okay, the manifest is ready, you're good to go. If you want to deploy it, just run Copilot deploy. And that's all you need to do. If you want to create a new deployment environment, right now we have both test and prod PDX. I can type Copilot env, and that tells me that these commands are for environments, and then environments are deployment stages that are shared between services. So I can type Copilot env init, and I can say, for example, I want prod IAD, and then I choose which name profile I want to use for my new deployment environment. So with this, I can choose, for example, prod, and that will deploy to a different AWS account as well as a different region. And then you will get a new deployment stage available to you. With Nathan, we showed earlier how we can do Copilot deploy to manually deploy our change. But another command that was available to us was Copilot pipeline. So this is how I would set up my continuous delivery pipeline and satisfy our 3rd design tenet of the CLI. So if I go to Copilot pipeline to see which commands are available for me, I can initialize a new one, I can update my pipeline, delete it, see the status of my pipeline, show some configuration settings of my pipeline. And let's show how we would set up a new pipeline. So I would type Copilot pipeline init. And then you choose the order of deployment for your environment. So I'm going to say, I want to first deploy to a test environment. Then I want to deploy to production. This is the location of my GitHub repository. So the CLI detected that. And then it asks me for the personal access token to access this repository so that the pipeline can pull the code changes and then deploy them. I'm gonna quickly copy my access token, paste.
I just want to say good job with not accidentally leaking your GitHub token to Twitch.
Yeah, it was practice. And but if we take a look at the pipeline file, you can see that it's a very minimal configuration that you would need for a continuous delivery pipeline. It says that the source is a GitHub repository. This is the name of the repository. This is the branch that we should be using, for doing our releases. And these are the order of our deployment environments. First, we're going to deploy to test and then to production. And if we do pipeline update from here, let me show you quickly how the end result looks like. So I'll switch over to the code pipeline tab. Let me go under pipelines. And this would be the pipeline that gets generated. So the first stage is going to be the source stage that's just going to pull the changes from your GitHub repository. Then in the build stage, we're going to build each one of the container images for each one of your microservices. So for admin, for API, as well as for the site microservice. Then we're going to start our deployment. So first to the test environment and then to the production environment. Each one of them will create a different CloudFormation stack for your microservices. And you don't have to go to the console to be able to visualize the status of your pipeline. You can always stay within your terminal. You just type CoPilot pipeline status, and you get to see what the pipeline looks like. This transition I enabled. My previous deployment was successful. So just to recap, right? We've seen how to get started with the CLI, with the CoPilot, getting started commands. We saw how to operate with the CoPilot service status command, service show. I didn't show CoPilot service logs, so we can do that really quick. Oops, typo. And I can choose, the vote site service in the test environment, and that will start displaying your logs. So that will be the operational commands that are available to us. We show how we can set up a continuous delivery pipeline by using CoPilot Nvinit as well as CoPilot Pipeline Init. That's roughly what I had for the demo.
That's amazing. I just want to say this is a full toolkit. This is a toolkit that probably a large company, they would probably build from scratch, perhaps, in order to be able to operate with multiple services. And here, I don't have to build this from scratch. It's already there. It's already released. It's maintained by Amazon and AWS. Obviously, I see there's a lot of issues on there. Clearly, I imagine the team is probably looking for suggestions and things to work on from those issues.
Yeah.
That's awesome.
Yeah, so, go ahead, sorry.
I was going to ask, what can you say about what's next? What's coming down the line for CoPilot?
Great question. So, we had many requests for being able to, instead of us creating a VPC and all this networking configurations, such as the subnets, the CIDR ranges in your VPC, people have already existing VPCs, and they just want to use that with CoPilot. So we're actively working on that right now. So if you go to issues, issue number 740 is request. You can expect minimal patterns to be added to the CLI, right? Right now we have 2 patterns that are available, the load balance web service pattern, as well as a backend service pattern. We're working on adding a scheduled service pattern so that, on a daily basis, a scheduled task is triggered or something like that. And then, we would love to hear from you for what more we can do in the operational space. So what would you be looking for besides log and being able to see the status of your service?
Yeah, if moderators haven't already, I see that. Drop a link into the chat for this GitHub repost. That way everybody can go check it out. I see we got a few more stars on the repo just during this session, so it's exciting to see more people checking it out. And feel free to test it out and leave a comment in the issues if you run into anything that you'd like to see us improve. We're always looking for more stuff to work on, obviously. That's very cool.
Yeah. And This is the link to our documentation if you go to the README, and we have installation. We have also instructions on how to install the CLI under the installing section.
So we're just installing with Brew. Okay, so it's very, very easy to get started with installing Copilot on your own development machine, and encourage you to do so and check it out. Is there anything else that you want to tell the audience, or any questions we can? I see one question from the audience: will Copilot support PowerShell? I imagine that's asking about Windows environment then. So it's actually a question I have seen a couple times from people asking, will Copilot support Windows?
Yeah, so we have a Windows binary right now in our, if you go to the releases for the CLI, but our current recommendation is that would prefer if you would use the Linux or the Mac OS binary. We have heavily tested both of these binaries. So if you can use the Linux subsystem for Windows and then install the Linux binary, that would be the preferred route.
Yeah, that makes sense. That makes sense. Cool. Well, thanks a lot for showing us this demo.
And thanks for joining.
Yeah, I'm excited about Copilot and seeing where it goes and what kind of applications people develop with it. Where can the audience reach out to chat with you more afterward if they have more questions?
Yeah, so we are super active on, in the Copilot repository. So if you got us an issue, we'll get back to you very quickly. Alternatively, we also have in the README, you can see that there's a chat button over here. So you can also chat with us live on Gitter.
Oh, that's perfect. Yeah, people will be able to ask questions live to the team if they have any questions about Copilot. That's fantastic.
Mm-hmm.
Well, thanks a lot for doing this demo and talking about Copilot. And
thanks, Nathan.
We'll move on to the next segment.
Oh, I just realized I was muted on the stream, so folks that were not in the call were not able to hear me. Yeah, thank you. You all caught that. Well, as I was stuttering over myself, I was about to say that I feel like one of those reviewers that is back again reviewing a product that they get on a monthly or a yearly basis, where it's like 2020 is the best and biggest year for X. Except it's AWS What's Next, where you always say, this is the biggest episode yet. And, I hesitate to say this, but I think this will probably be one of the hardest to beat due to sort of the gravity of the launch of IVS, being able to have Emmett, have Marty on. This was a great episode, but Rob, we're 3 hours in. Lots of people have probably just tuned in now or caught us midway through. For those who haven't been here the whole time, what have they missed?
Oh man, it's almost impossible to summarize all the excitement. It hasn't felt like 3 hours, honestly. We've been having so much fun. We started off with the announcement for IVS, Interactive Video Service, and what we can do there is basically take all of the infrastructure improvements we've made to Twitch over time and package it up as a service so that you can publish your video stream, have really low latency to all sorts of mechanisms of distribution, and an SDK that allows you to integrate that with your native apps, your web apps, just some really exciting stuff. I really can't do it justice. You got to check it out.
Yeah, I mean, I feel like you promise something that's exciting and then you make it even more exciting each time you talk about it, where it's like, oh yeah, it is easy to integrate. Yes, in an hour you can have your own live video. Yes, in just 2 minutes you can have your own channel and have all the infrastructure provided. And like being able to see that demo in the console of just 3 clicks or a single SDK call, spin up a channel and return a set of credentials to a user, and just have everything else abstracted away. Like how far we've come from literally right before IVS, right? We're not talking about improvements over what things were like a decade ago, but if you're using something like IVS, or I shouldn't even say something like IVS, because I can't point to anything that is quite similar to IVS. It is just light years ahead with respect to the experience and the simplicity that it offers for developers. Right after this call, you can, or this show, if people haven't already, you can go and fork some of those samples and just plug in your own credentials and get started building your own streaming platform. Like that, those are words we could not have even hoped to utter without cracking ourselves up because of the gravity of such a task just a week or two ago.
Yeah, and really, like if you think about the technology here, this is one of those things that almost seems unremarkable if you don't quite grok the magnitude of the problems that it's solving. It seems kind of unremarkable, but it's one of these steps that subtly, people in Twitch chat right now who see this announcement, they're going to go away and they're going to start hacking on this. And in a couple months, a couple years, we're going to start seeing the fruits of that work. And we're going to see innovation. We're going to see experimentation. We mentioned some of the really cool integrations that you can do with the metadata API. We're going to start seeing that, right? We're going to start seeing people pushing the envelope for what it means to have this kind of interactive, live, rich experience online. And I think that's just so exciting to me. I really, but I think we've been gushing over IVS. I always get the acronyms mixed up. But I do think that we need to be fair to the other services. We had some really exciting announcements. And what I really like about that's consequently one of the cool things about this show, that we can cover things that are so different from one another, right? So we go from kind of live video streaming infrastructure to DeepRacer Evo. Nick, you want to talk about DeepRacer Evo?
Yeah, totally. I mean, I know there's like a racing sim category on Twitch, but I don't know if there's an autonomous driving category, or IRL maybe, I don't know, what have you. But the point being, DeepRacer is an autonomous vehicle, and while that sounds super daunting to try and even begin using, it is all bundled as a service for training and deploying a model to this vehicle for people who may have never used machine learning before. It's largely this educational tool that has a fun, exhilarating, competitive component to it in a virtual league. If you ever come down to an AWS summit in your local region, there's going to be a track there. You can get started. We'll have pit crew members there. And so this has been so great for the past, I think, since 2018 when DeepRacer initially was announced and rolled out. And the announcement we talked about today was DeepRacer Evo. Sort of DeepRacer bigger and better. I guess that's the theme of this show, right? It's just these things that people know and love, but bigger and better. And when you haven't heard about it already, it's something that was something you could have even imagined. And with DeepRacer Evo, use depth detection, LiDAR sensors. We saw that when Eddie actually had the DeepRacer Evo. He pulled the shell off, and we saw the spinning LiDAR sensor on top. In addition to the typical single camera, depth perception is calculated by having those 2 cameras. It looks like a set of eyes on the front of the car. We were able to see sort of what it looks like to actually load that model on it and see out of the front of the DeepRacer that he had sitting on his dining room table. So yeah, to jump from fully managed media streaming service or video streaming service with the CEO of Twitch, to then Eddie, this senior software engineer over on the Amazon AI team who's building services to help teach machine learning developers how to with machine learning through self-driving cars. And then third, we had Nathan and Fa talking about a container launch for the CoPilot for ECS. This is really quite the variety show we have going on here. If there was not an AWS logo at the bottom, I don't quite know how we would string all these things together. But I think that's a great segue into this final segment that we traditionally do on this show, right?
Absolutely. And I think we have the disembodied spirit of Nathan Peck still with us online. Nathan, can you try and say something?
Yes, I am here. I don't have a video slot on the screen, but yeah, I'm still here.
Awesome.
Okay. So this last section, just to kind of fill Twitch in, we have a fun little game that we play at the end of every episode of What's Next. And what we do is take all the announcements and we mix them together as though they were secret ingredients on an episode of Iron Chef. The idea is, how can we combine these to build the most interesting, wacky, silly, whatever service? And we usually like to put our special guest on the hot seat here. So Nathan, your secret ingredients are IVS, DeepRacer Evo, and CoPilot.
All right, I got a great idea. Okay, I didn't even have to think about this too long because it just all came to me. So IVS is all about interactive video stream, right? And we saw in the demo that you can have these controls or like polls pop up on screen. And I know that Twitch loves to play games via Twitch chat. To me, the clear thing is it'll be a live stream of what the Evo racer actually sees from its perspective. And the Evo racer will pop up poll on screen that asks, do I go forward? Do I go right? Do I go left? And that web application that actually deploys the IVS stream and the polling system would be deployed using CoPilot. So we can combine all three of these launches together and make a really cool automatic Twitch trains a Evo racer model.
You made this too easy for us. That was great. I mean, I was gonna joke during the DeepRacer session. I was like, "Yeah, games. When are we getting Twitch plays DeepRacer?" But with what you just described, that would quite literally be the architecture diagram for that.
Well, that's the thing. Like these technologies that we're talking about are so easy to integrate and so powerful that you can build this awesome stuff that never would have been possible before. And you can build it fast too. Like we could probably throw this together in like a day or two.
Maybe we should.
Sounds like another show.
Sounds like a live coding stream that needs to happen.
Nick, you think you can improve on that idea?
I mean, I don't know where I could I feel like I've been done up on my own segment here by our guest that we just sprung, our guest host Nathan, that we just sprung this on minutes ago. So I don't think I
didn't even know this was coming. So
I mean, he was so unprepared that we didn't even have a video tile for him here on this segment, but he still killed it. I'm trying to think if there's a way I can improve it, but it's not only a seamless integration, but it's almost like there's very few other moving parts you'd even need to make that possible, right? Like your front end of your application would literally be your streaming platform, right? So just like any basic web app, and then the web app that's going to interface with your vehicle would be containerized and deployed through CoPilot. So quite literally, the only thing you'd have to slap on there is some sort of basic front end to host the IVS stream and handle user input. But I feel like this is the most complete application, and I would have never guessed it based on the services we had slated for this episode.
Well, it's all inspired by Twitch chat talking and asking all those questions about the Evo Racer and like, can you make it go faster? Can you do this or that?
Yeah, again, chat was great today. Lots of great ideas. I know we always say on the show, like, hey, we're bringing service team members on here. Let them know your unadulterated thoughts, the ridiculous ideas, because that's how things like DeepRacer started, right? And so it's no holds barred when we're trying to consider what the next big thing could be here at AWS.
Absolutely, yeah. I have nothing to add to that. I cannot top that entry, Nathan.
Yeah, well,
thanks.
We're stumped, Nathan. Like for a barometer here, usually Rob and I, like, one of us will integrate tie two servers together, and we pass it off to the other person to tie in the third, and you just did us up. So maybe we'll have to bring you on just for this end segment again, or we'll have to have Nathan's picks, and we'll give you it in advance and compare our answers like an envelope, right? Like at the Oscars, we'll open it up and be like, and Nathan said. We'll figure it out. But this last segment evolves. Like each episode, I feel like we while we're on that holding screen, we go like, hey, so what if we did this here at the end too? And it just gets better and better each week. So, awesome. Well, we're at about 3 hours here on the broadcast. Again, AWS What's Next live show covering the latest launches here from Amazon Web Services. Amazon IVS interactive video service, AWS DeepRacer Evo, and then lastly we got to see AWS CoPilot. 3 very different launches: media services, autonomous driving and machine learning education, and containerization. But I think it all tied together pretty well. And for those of you in the audience that stayed through the entirety of the time, I hope you enjoyed. In the same way we do this Iron Chef exit at the end and try and imagine what application would tie all these together. I sometimes wonder who in the world it would be the perfect developer that would be like, oh yes, these are the 3 services I wanted to hear about today. But I see some familiar names that have stuck through in the chat, so I hope you enjoyed. If you have any feedback on the show, things you would improve, things you want to see, things you liked today that you'd like to see more of. Like on our side, we loved having Nathan as a guest host here. I know you can't see him, but that was a lot of fun, and Nathan was able to cover a bunch of stuff that Rob and I may not have been able to with containers. So maybe we'll bring that back to the show in a different capacity in future episodes. So follow on Twitter. Rob and I, we have our links in the chat. There will be a video on demand of this, both on Twitch but also on YouTube. We'll have a playlist link there as well, where you can follow along and see all episodes uploaded on there. And there's also a podcast. We're on most major podcasting platforms. We'll drop some links there. I'll leave it on the final screen. Spotify and Apple Music, I'm pretty sure at the very least. There's a few others as well. But Rob, any closing thoughts on quite literally the largest episode of What's Next yet?
Just that our next episode is on August 7th, I believe, noon Pacific. So mark your calendars.
Yes, August 7th. We do this show every 2 weeks, or as closely to that cadence as we can. There's lots of exciting launches. If we could get any closer to the launches and stream day of, we would. But hard to coordinate with a lot of moving pieces there. But yeah, I had a blast. Chat, I know I heard some great things there, and I'm looking forward to the next episode in 2 weeks. So without further ado, Twitch, we're signing off for today. If you enjoyed this content and you're not already following, oh dear, it's upside down. Follow along at twitch.tv/AWS, the channel you're watching on right now, or you're on LinkedIn and you're not on Twitch, in which case follow along. You'll also get notifications there. Yeah, I think that's going to about do it. I'm really happy with this episode, and I'm excited for the ideas that I have for future episodes as well. But happy Friday, everybody. Have a great, relaxing weekend, and we hope to see you back here in about 2 weeks.
Bye, everyone.
Take it easy. Have a good one, everyone.